One more second, y'all. All right. Happy Friday, everybody. We are live from the Alpha Esports Technology Center. You see the title, AWS Cloud Quest, final day, maybe. We're going to try to get this done. I thought I had a little bit more time, but with the Monday being a holiday, and then summer starting, and we have our summer camp starting next week, and a couple other things that came up, including the fact that I will be speaking at not one but two panels at MomoCon this weekend. The time that I thought I did have, is cut short drastically. So quick rundown. Thank you for everybody who is watching. We are live streaming on multiple platforms. We are on Twitch, YouTube, LinkedIn, Facebook. So shout out to everybody watching wherever you're watching. Again, please support by just liking the video, subscribing to the channel, clicking the bell for notifications so you can be notified when we go live, and sharing the link. Like I said, you could be anywhere. It's Friday. I mean, it's Memorial Day weekend. Shout out to all the veterans who have served. Thank you for your service. You will not be forgotten. One more second, y'all. Give me one more second. Sorry about that, y'all. It's been a busy day. So, like I said, so thank you for watching. We are going to go ahead and just get started with the stream because, again, we want to get done. We were been enjoying it so far. Been enjoying the experience. Really like what Amazon is doing with their Cloud Quest. I think there's going to be a lot more that they can build on. One thing they need to, if I had to criticize one thing, I would say they just have to fix those voices. It's kind of painful to listen to. So let's see. So just to kind of give a quick rundown, we've completed six objectives so far, and it says we have 4 more. So we have core security concepts, first NoSQL database, cloud economics, and then file systems in the cloud. So those are the ones that it says we have left. So we're gonna just kind of jump on that, and then, like I said, we'll see what happens because it says there are 6 more things we have to do to get our recertification status. So let's go ahead. Remember, they want us to create IAM, so identity and identity and authentication, or identity and access management. I'm sorry. They want us to set up different groups for support engineers. They want us to attach a managed EC2 read-only access policy to a group, and then they also want us to create and attach a user group membership. So we're going to go ahead and hit start. We're going to have to go through these videos, y'all. So just suffer with it with me, y'all. Just come on. We'll get through it together. Like I said, we want to knock out these missions and get it going. And if you aren't familiar with this, we're doing our AWS Cloud Quest for our cloud practitioner certification, or recertification, I should say. But we're also just doing Q&A. Figured I'm gonna do it. It's a gamified thing. We have a gaming center. We talk about cybersecurity and tech. So figure why not, right? Just make a little bit of content and engage with our viewers while doing so. So if you have any questions, you can leave them in the chat. Let me know what you're doing for this weekend. If you're in the Georgia area, let me know if you're going to be at MomoCon. I'd like to see you in person, meet you there. Like I said, I'm on 2 panels. I'm on a panel for esports and game development in Georgia. And then the other one is is basically parenting in the digital age. So that's about keeping your kids safe online. So I will be speaking on both of those panels. And then, like I said, I'll be there pretty much. I'm there from Saturday afternoon after our esports practice. I'm shooting straight down there. So I'll probably be there from like 1 to, I don't know. We'll see. And then Sunday I'll be there because the talk is at 1. And then Monday, the panel is at 2. So obviously I'll be there in those time frames. So if you're going to be at MomoCon this weekend, let me know. If not, just let me know in the chat what you plan on doing this weekend. All right, let's go ahead and get to these videos, if they will let us get to these videos.
Welcome to an overview of cloud security on AWS. In this lesson, you will learn about the benefits of using AWS's secure infrastructure and services. With AWS, you will gain the control and confidence you need to securely run your business with the most flexible and secure cloud computing environment available today. AWS customers benefit from AWS data centers and a network architected to protect your information, identities, applications, and devices. Automating security tasks on AWS enables you to be more secure by reducing human configuration errors, giving your team more time to focus on innovation and scaling. Select from a wide variety of deeply integrated solutions that can be combined to automate tasks, making it easier for your security team to work closely with developer and operations teams to create and deploy code faster and more securely.
But I'm gonna leave it alone.
AWS is vigilant about your privacy. All data flowing across the AWS global network is encrypted at the physical layer before it leaves our secured facilities. And additional encryption layers exist, such as with VPC cross-region peering traffic and service-to-service TLS connections. AWS also features fine-grained identity and access controls that ensure the right resources have the correct access at all times. For compliance, AWS regularly achieves third-party validation for thousands of global compliance requirements to help you meet security and compliance standards for finance, retail, healthcare, and more. AWS is also the only commercial cloud that has had its service offerings and associated supply chain vetted and accepted as secure enough for top-secret workloads. You can extend the benefits of AWS by using security technology and consulting services from familiar solution providers within the AWS partner network. AWS Security Services helps you define user permissions and identities, infrastructure protection, and data protection measures for a smooth and planned AWS adoption strategy. You can also gain visibility into your organization's security posture with logging and monitoring services, then ingest this information into a scalable platform for event management, testing, and auditing. AWS enables you to automate incident response and recovery to help shift the primary focus of security teams from response to analyzing root cause. With AWS, you can utilize event-driven automation to quickly remediate and secure your AWS environment in near real time.
I like the fact that you can automate. Well, you can automate a lot of your IR, your DF, and disaster recovery. All right, let's go to the next one.
Welcome to a brief lesson on the AWS Shared Responsibility Model. The AWS Shared Responsibility Model details the division of responsibilities between AWS and customers. This differentiation is commonly referred to as security in the cloud, which is the customer's responsibility, versus security of the cloud, which is AWS's responsibility. Security and compliance is a shared responsibility between AWS and the customer. This shared model can help relieve the customer's operational burden as AWS operates, manages, and controls the host operating system and virtualization layer down to the physical security of the facilities in which the service operates. AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud. This infrastructure is composed of the hardware, software, networking, and facilities that run AWS cloud services. For customers, they assume responsibility and management of the guest operating system, including updates and security patches, other associated application software, and configuration of the AWS-provided security group firewall. Customers should carefully consider the services they choose, as their responsibilities vary, depending on the services used, the integration of those services into their IT environment, and applicable laws and regulations. Customers are also responsible for managing their data, including encryption options, classifying their assets, and using IAM tools to apply the appropriate permissions. Let's take a look at how responsibilities change, depending on the AWS services selected. Amazon EC2 is categorized as Infrastructure as a Service, or IaaS, and as such, requires the customer to perform all of the necessary security configuration and management tasks. When working with EC2 instances,
Basically, what they're
customers are
saying,
responsible for
they're just
resources
kind
in
of
the
showing
cloud,
you who's
which includes
responsible
customer
for what,
data, the guest operating
what
system,
the
including
expectations
updates and
are,
security patches,
and
application software,
basically
IAM
who to
policies,
blame if
networking and
something
firewall
goes wrong.
configuration, client-side encryption, server-side encryption, and network traffic encryption. AWS is responsible for security of the cloud, which involves protecting the infrastructure that runs EC2 instances. This is composed of virtualization software for compute, storage, database, and networking services. The underlying hardware within each data center that comprises the AWS global infrastructure, and the physical infrastructure that supports AWS regions, availability zones, and edge locations. With AWS Lambda, the responsibilities change, as customers must manage the security of their code, and identity and access management to the Lambda service, as well as within their functions. More specifically, customers are responsible for managing customer function code libraries, resource configurations, and identity and access management for Lambda functions. When using AWS Lambda, AWS is responsible for managing the underlying infrastructure that includes the compute and execution environments, the Lambda runtime language, networking infrastructure, the server software, underlying hardware, and the facilities that support the regions, availability zones, and EC2 hardware.
Okay, so now we just going.
AWS Identity and Access Management, IAM, Overview. AWS Identity and Access Management, AWS IAM, enables you to manage access to AWS services and resources securely. An IAM user is an entity that represents the person or application that interacts with AWS. An IAM group is a collection of users. Each user in the group inherits the permissions of the group. Using IAM, you can create IAM users and groups and manage them. IAM controls who is authenticated in order to sign into AWS. Each user is assigned with an individual security credential. By default, IAM users cannot access any resources in your account until you give them permissions. You need to apply an IAM policy to grant permissions in order to allow and deny their access to AWS resources. You can also use IAM roles to delegate access to users, applications, or services that don't normally have access to your AWS resources. When you assume a role, it provides you with temporary security credentials for your role session. IAM is a feature of your AWS account, offered at no additional charge. You will be charged only for use of other AWS services by your users. Here are the common use cases. IAM provides fine-grained access control to AWS resources. IAM also enables you to add specific conditions, such as time of day, to control how a user can use AWS, their originating IP address, whether they are using SSL, or whether they have authenticated with a multi-factor authentication device, or MFA. IAM helps you analyze access across your AWS environment. Your security teams and administrators can quickly validate that your policies only provide the intended public and cross-account access to your resources. You can also easily identify and refine your policies to allow access to only the services being used. This helps you to better adhere to the principle of least privilege. By using multi-factor authentication for highly privileged users, you can protect your AWS environment. Once activated, signing into MFA-protected account requires a username, password, and a valid MFA code provided by an MFA device, either a hardware MFA token or a virtual MFA device such as an MFA-enabled mobile device. IAM can integrate with your corporate directory by enabling identity federation. It can grant your employees an application access to AWS Management Console, AWS Service APIs, and resources using your existing identity systems, such as Microsoft Active Directory, or any identity management solution that supports SAML 2.0.
Man, they got to have an option to let you share multiple screens because I got to do a little multitasking here. The Rainbow Six championships are on, so
AWS Identity and Access Management
I got
features
that playing
manage
on the
IAM
center in the
permissions.
TV.
Permissions are granted to
I have to
IAM
go back and
entities,
forth.
including IAM users, federated
Oh,
users,
that,
groups,
that
and roles.
getting it done
To
the
give
last
entities
day looks like
permissions,
it might
you
be
can
a
attach a policy.
little
A
bit
policy
difficult.
consists of one or more statements, each of
But
which
we'll
describes
see.
one set of
What's going
permissions. Version: specify the version of the policy language that you want to use. SID is optional and specifies the statement ID to differentiate between your statements. Effect: specify whether to allow or deny access. Because access is denied by default, you typically write policies where the effect is to allow. Principal specifies the IAM entity that is allowed or denied access to a resource. Action includes a list of actions that you allow or deny. And here are some action examples for S3 service. Resources specify which AWS resources you allow the action on. Conditions specify which conditions must be present for the policy to take effect. For example, you might allow access only to the specific S3 buckets if the user is connecting from a specific IP range or has used multi-factor authentication at login. You create policies by using either the visual editor or JSON. The visual editor guides you through granting permissions by using IAM policies without having to write the JSON syntax. You simply choose the service, actions, resources, and request conditions to generate your policy. You can still author and edit policies in JSON, if preferred. The following policy example was created with the visual editor. This policy is for Amazon S3 service. It grants 4 list actions and 1 read action to the S3 bucket and objects. In sample bucket, if the prefix starts with my prefix. To make it simpler to choose with AWS services actions, they are categorized in these access levels: list, read, tagging, write, and permissions management. If you use the AWS Management Console to manage permissions, you can view policy summaries. A policy summary lists the access level, resources, and conditions for each service defined in a policy. AWS Identity and Access Management features manage IAM roles. An IAM role is an AWS identity with permission policies that determines what the identity can and cannot do in AWS. It has a many-to-one relationship. You can enable many users or applications to assume the same role to grant the same set of permissions. A role does not have standard long-term credentials, such as a password or access keys associated with it. Instead, it provides you with temporary security credentials for your role session. The following scenarios highlight some of the challenges that you can address by delegating access using roles. To grant applications on an Amazon EC2 instance access to AWS resources, developers might distribute their long-term credentials to each instance. Applications can then use those credentials to access resources, such as Amazon S3 buckets or Amazon DynamoDB data. However, distributing long-term credentials to each instance is challenging to manage and a potential security risk. Therefore, the best practice is to use an AWS service role for an EC2 instance. Applications running on that instance can retrieve temporary security credentials and perform actions that the role allows. Cross-account access. To control or manage access to resources, such as isolating a development environment from a production environment, you might have multiple AWS accounts. However, in some cases, users from one account might need to access resources in the other account. For example, a user from the development environment might require access to the production environment to promote an update. Therefore, users must have credentials for each account, but managing multiple credentials for multiple accounts makes identity management difficult. Using IAM roles, you can take advantage of cross-account access to give users access across AWS accounts when they need it. Granting permissions to AWS services.
So that
You can use AWS IAM roles to grant permissions for AWS
services.
services to call other AWS services on your behalf, or create and manage AWS resources for you in your account. AWS services such as Amazon Lex also offer service-linked roles that have predefined permissions and can be assumed only by that specific service.
I said it's rough. Like I said, I be feeling like I have all the energy in the
AWS
world,
Identity
and
and
then
Access Management features, access analysis.
the voice.
IAM Access Analyzer
Voice
generates
starts-
comprehensive findings that identify resources that can be accessed from outside an AWS account. It evaluates resource policies using mathematical logic and inference to determine the possible access paths allowed by the policies. IAM Access Analyzer continuously monitors for new or updated policies, and it analyzes permissions granted using policies for your Amazon S3 buckets, AWS KMS keys, Amazon SQS queues, AWS IAM roles, and AWS Lambda functions. IAM provides you service last access data, which is a timestamp on when an IAM policy or entity, such as a user or role, last used a service. From the AWS organization's master account, you can also see the service last accessed by the organization root, organizational units, and accounts. Here are the key benefits. Saves time analyzing resource policies for public or cross-account accessibility. Compared to heuristics or pattern matching techniques that could take days or weeks, IAM Access Analyzer can quickly analyze thousands of resource policies in seconds, thus saving time. It delivers detailed findings through the AWS IAM, Amazon S3, and AWS Security Hub consoles, and also through its APIs. Continuously monitors and helps you refine permissions. IAM Access Analyzer continuously monitors and analyzes any new or updated resource policy to help you understand the potential security implications. In addition, with the service last access timestamp data, you can easily identify and remove unused permissions to improve your security posture by granting only the permissions required to perform a specific task. Provides the highest levels of security assurance. IAM Access Analyzer uses automated reasoning to comprehensively summarize which resources grant public or cross-account access. We call these analytical results provable security, a higher level of assurance for security of the cloud and in the cloud. This is how it works. First, create an IAM Access Analyzer for your account. The analyzer will continuously scan supported resource policies within the account. Then, review the detailed findings for resources that are accessible from outside the AWS account. Next, take action. If access to the resource is not intended, modify the resource policy to further restrict access. If the access to the resource is intended, then you can archive the finding.
All right. Okay, so let's try to go through the diagram real quick. So we're going to use IAM to provide work permissions to engineers by using group settings and a least privilege principle. So if you don't know, and they talked about it, least privileges is giving people access, only the access that is required for them to complete their job functions, nothing more, nothing less. So if your function is to access the database, then you are only given access to the database and the database alone, and to perform your whatever is necessary to perform your job functions. Okay, so that's the concept of least privilege. So we're going to go ahead and we're going to do that. The solution is going to use the AWS IAM to create a support engineers group with limited permissions. It says first the user group is created. So that's, I think we touched on that.
AWS Identity and Access Management.
So we did that. We're gonna use the manage permissions to create our group. And then we're going to do a read-only access policy for the EC2 service to the support engineers group. Then IAM users are going to be created and added to that user group. They'll also inherit whatever permissions that are set, the policies that are attached to the group. And then the policies and then multiple policies that can be attached to the same user group or find a permission. All right, so not going to waste any time. So our lab is to create the group and the users, and then we're going to attach the managed policy to the group of users. And then we're going to also, for the DIY, we're going to grant support engineers group read-only access to RDS over here. All right, so let's get it going. What's going on? Hey, man, I called you the other day, but you didn't answer the phone. So are there any lab files? There are no lab files. So we're going to open up our lab. We are surviving, brother. We are surviving. Go ahead and share. Again, make sure we are a lab user. Make sure we're in the proper environment. We're good to go. Make sure we're in a good region. We're in the North Virginia, US East. So we'll go ahead and get that started. So first thing we're going to do is we're going to type in IAM. Not IMA, IAM. And we're going to open up our identity and access management module. And then from there, we are going to go to the user groups and we're going to create a group. So we're going to go to user groups, click create a group. And then we're going to name our group support engineers. Support engineers. All right, and then we'll just go down to the attach permissions policies down here. And in our attach permission policies, we are going to do EC2 read-only access. So EC2 read-only access. Oh yeah, how'd it go? How do you think it went, I should say? Amazon EC2 read-only access. You know, we should. Hey, man, congratulations. Congratulations. That's awesome. That is awesome. Especially, no, that's great. Proud of you, brother. Congratulations. All right, so we're going to go ahead there. And then we're going to create the user group. Now, but before we do that, what is it? It said grant support read-only access to RDS. You know what? So we should have 2 permissions set. So we're going to go ahead and create the user group. Oh man, let's start from the beginning. So I'm just cheating again, y'all. I'm cheating. I'm gonna try to knock out the do-it-yourself and the lab. So this is support engineers group, right? Because we needed to name it the support engineers group. Yep. So support engineers, and now we need to give it EC2. We need to give it EC2 read-only access, which we are. And now, but the do-it-yourself said give it RDS as well. So we'll go ahead and we have those two. And now we'll just go ahead and create the user group. So like I said, so basically what I just knocked out both of them, but we'll we'll still go through it. Hey man, that's good. That's good. So you're doing a security analyst. You do everything blue team related and some pen testing. Yeah. So you'll probably do some like Nmap scanning. You'll probably end up having to test out some exploit modules and stuff like that to see how to add those modules and signatures to your monitoring and logging in your SIM tools. But that's great. Congratulations, man. And to answer your question, I think that just briefly, who's paying for it? If you know what I was talking about. All right, so let's see. All right, so anyway, let's go here. Create group, create next step. So now on the left thing, we have to go ahead and create a user. And then we're going to create a user named support engineer. So we're going to go here, go to users, create a user, and we're going to go support. How do I want us to do it? Support engineer 1. Okay, so you say you're okay, but reimbursed. Oh, well, if you're going to be reimbursed, I mean, go for it. Only reason I would say so is because I get it. Like I said, a lot of companies are still looking for it. So it doesn't hurt, right? It doesn't hurt. So like I said, if you're going to get reimbursed to do it, and then like I said, it's still what they look for in DoD, then go for it. Do we want to provide user access to the AWS console? We'll say yes. We're going to create a custom password, and then the password will be I think that's what it said. Nope, that's not what it said. Okay. We do not. User must create. We're gonna clear that, and then we're going to go ahead and scroll down, which we're good, and then we'll go there. Yeah. Oh yeah. Absolutely. You're probably gonna be. Well, I shouldn't say absolutely, but yeah, you'll definitely do some AWS stuff. All right. We have to set our permissions. So we have that. We have that. We have that. So we'll go ahead and click next, and now we will. Okay. The password that it told us to create for our lab was recently found in a data breach from Google. So that's good to know. All right, so we're going to add a user to a group. So we have that, and we're going to go ahead and click the support engineers group. We're going to click next. And then hold on 1 second, y'all. All right, y'all. Sorry about that. Like I said, it's summer, so everybody's home. All right. So basically, what I just did while taking that, we just added our value. We did the job title and the support engineer. Again, we're creating a user and adding tags for that user to go into the. So our user support engineer is going to have the job title, support engineer, and then they'll be added to that support engineers group. So we'll go ahead and create user. So now our user was created successfully. And now when we go to, we have to go to the retrieve password step, which we're right here. We're going to go ahead and click this sign in URL. And because we're going to need to sign into that, the AWS console. So the AWS management console to make sure we have that. So we're going to just double check, make sure we're good. We're good. We're copied. So now we'll return to our users list. Hold on. Do we need to download the console password? I don't think we need to download the console password since we are just doing this for the lab's sake. So we'll just hit continue. All right. So now we will open up a new browser, go into this, hit here, and now when we do that, it's going to tell us we need to use our username and password that we just created. So support engineer 1, and then our password was all right. And we are going to sign in. Yes, we know Google. So now we signed in successfully, and now if you look, we're in the support engineer 1 in that group. Hey, how you doing? And now we're going to go ahead and hit EC2 because we need to connect it to an EC2 instance. So once we go there, we're going to make sure we are in the North American, US East, North Virginia 1 region, which we are, US East, North Virginia, yep, US East 1. Do you think Nate? I mean, I think so. I think they got to pick their, they got to do their testing and hands-on. I don't know. I don't know if they take if certifications or whatever, but I definitely know their training is, they definitely have trainings and hands-on elements to it. So, all right, so now we have our web server running and we need to check that and terminate it. So we're going to go here and then we're going to click on the instance state. We're going to terminate the instance. Oh, and it looks like it gives us an error message. And I think it's giving us an error message. So it says in the error. Okay, so basically we don't have permissions to do it. So again, we created access that we only had read-only access to the EC2 instance, if you remember. So because we only have read-only, we can't write, we can't make changes. We can only see. So we can access it, but we can't do anything else. So that's how you know we did what we were supposed to do. So our users been created. All right, so we can now go ahead and believe we can stop sharing. So we will come back over here, go here, we'll close out of here, close out of here. Hold on. My YouTube on another tab. All right, so we're good there. So now we're going to go to the do-it-yourself. Oh, it wants us to do the validation. It wants us to create, we'll verify the support engineers group. So that was, like I said, we did it as support engineers. We're going to hit validate. And like I said, remember, we did that a little bit earlier. So remember when we created our group, we gave it an EC2 read-only access, but the DIY section said you had to give it RDS read-only access as well. So we just added that while we were there. All right, so now we get another reward. Hold on, we have a skyscraper with a helipad. Looks like some type of amusement park, and then this looks like a castle, with a barn. I'm gonna go with the helipad because I got to suit it. I'm suited and booted, so I gotta be I gotta have my helipad, my fancy helipad. All right, cool. So it said I'm looking. We have a new builder level. All right, so far so good, right? We've been streaming now for a little under an hour, and we got one challenge done. So we're getting there. All right, so we got 3 more left. So we got NoSQL database, cloud economics, file systems in the cloud. You know what? Let's just do it in order. And while we're traveling, so like I said, do you think nation states use the same methods? I think so. I don't see why not. I honestly, they probably have. I mean, their training's probably a little bit more intense. It's probably a little more technical. So I don't see why not. And then how do you handle stagnant career development? Challenge yourself. I mean, it all depends on what you look at as career development, right? If you're looking at career development solely on what you're doing, what you're studying, what you're getting, what you're preparing, what certs you're getting, you can't. In that case, only you could make yourself stagnant. If you're looking at career development and jobs and stuff like that, I mean, unfortunately, you don't have full control over all of that. And in this economy, and how the job market's going, a lot of jobs there's not a lot of movement. So you can control what you can control, right? Way I see it, or the way I've always done it, is I know the job I want to get, and then from there I go with whatever training or certification or education I need to get, and then I put the ball in their corner, right? So now here it is. It's okay. I did these certifications. I did these trainings. And when you walk in there, you have more leverage. Like, we both know what the market dictates for someone with this level of experience, this level of training, and my work ethic speaks for itself. So it's up to you now to determine how you want to move forward. You have a chance to see what you're going to do to keep me, or I can start looking elsewhere. I mean, obviously, it's not that bold. You're not saying it that boldly, but again, if your goal is career development or career, just to kind of keep moving up in your career, that's how I would go about it. Don't wait on anybody to dictate what you need to do. Look at, like, when I knew I wanted to be a pen tester. I knew I wanted to be a pen tester when I was doing desktop support. So I did desktop support. I was like, okay, well, let me finish up my server, my Microsoft server certifications, got all those certifications. And then from there was like, all right, cool. Now I'm gonna jump over to becoming a pen tester. I recertified my Security Plus, and then I went ahead and started looking at pen testing stuff, and I did it on my own. So now when the time came, I had my experience from labs. I had my experience. I did pen testing, and then like I said, I sat there for a minute, worked on my craft, and then was like, all right, cool. What are we gonna do? Are we gonna make an official role here where I'm at, or do I have to go elsewhere? And they were like, well, there's nothing we could do about that. All right, cool. I went and got a pen tester job. And then when I was in a pen tester job, and then I started doing more work that was beyond a junior level. It was like, okay, well, I know I wanted to do more web stuff. So I started looking at web, so it's like, you have to kind of take that initiative. And like I said, if they, if that, as far as the job market is concerned, I'm not going to tell anybody to just go ahead and, throw yourself out there and put yourself in the running for a new job, especially when, jobs are slim these days. So, I guess the answer to your question is just that your outlook on what career development is. If you feel like your career development is stagnant, you actually have control over that. You don't have control over whatever the promotions or jobs are, right? But you do if you make yourself marketable. That's the only way I could put it. All right, so this one we're building a SQL database. Welcome to the best streaming. Thanks for answering the call. We want to add more features to our streaming services, which would require a highly scalable database with lightning fast performance. One feature idea is to have a digital bookmark so that customers can continue watching shows where they left off. Can we accomplish this without having a well-defined schema? That would be a nice feature to add based on what you described. And Amazon DynamoDB is the best option. DynamoDB is a NoSQL database, so you don't have to worry about a schema. It automatically scales and it has single-digit millisecond latency. What about gathering metadata on viewing habits of customer devices? Can the NoSQL database prioritize a large amount of metadata and support the storage? Okay, it supports petabytes. And to support your metadata needs, you can add records with unique IDs that have varying attributes. Okay, it will greatly enhance our customer streaming experience. Great. All right, cool. So we're going to be building a DynamoDB table, and we're going to create a DynamoDB record with metadata attributes. So again, we're going to create a database to help our video streaming team track customer viewing behaviors from metadata, such as movies, watched, and device type. This solution uses Amazon Dynamo, learn how to talk, Davin, DB, which has a flexible schema, so each row can have a number of attributes at any point in time. All right, cool. So we have that. All right. So now let's go into the video concepts, and then
Amazon DynamoDB.
I just want to make sure that those are the same videos. All right, so
Amazon DynamoDB overview. Amazon DynamoDB is the key value and document database. It delivers single-digit millisecond performance at any scale. It's a fully managed, multi-region, multi-active, durable database with built-in security, backup and restore, and in-memory caching for internet-scale applications. DynamoDB can handle more than 10 trillion requests per day and can support peaks of more than 20 million requests per second. Here are the key benefits. Performance at scale. DynamoDB is a key value and document database that can support tables of virtually any size with horizontal scale.
Like I said, I hope I answered
DynamoDB is both a key value and document data models. It enables flexible schema, which allows you to adapt to your business requirement change easily. For use cases that require even faster access with microsecond latency, DynamoDB Accelerator, or DAX, provides a fully managed in-memory cache. Using DAX, you can improve the read performance of your DynamoDB tables by up to 10 times. The time required for reads reduces from milliseconds to microseconds, even at millions of requests per second. DynamoDB global tables replicate your data across multiple AWS regions to give you fast, local access to data for your globally distributed applications. DynamoDB streams capture a time-ordered sequence of item-level modifications in any DynamoDB table and store this information in a log for up to 24 hours. DynamoDB provides both provisioned and on-demand capacity modes. Tables using provisioned capacity mode require you to set read and write capacity. For workloads that are less predictable, on-demand capacity mode takes care of managing capacity for you, and you only pay for what you consume. With the two capacity modes, you can optimize costs by specifying capacity per workload, or paying for only the resources you consume. For tables using on-demand capacity mode, DynamoDB instantly accommodates your workloads as they ramp up or down to any previously reached traffic level. For tables using provisioned capacity, DynamoDB delivers automatic scaling of throughput and storage. If your application traffic grows, DynamoDB increases throughput to accommodate the load. If your application traffic shrinks, DynamoDB scales down so that you pay less for unused capacity. DynamoDB integrates with AWS Lambda to provide triggers. With triggers, you can build applications that react to data modifications in DynamoDB tables. The Lambda function can perform any actions you specify, such as sending a notification or initiating a workflow.
It's just my
encryption
opinion.
DynamoDB encrypts all data by default. Encryption at rest enhances the security of your data by using encryption keys stored in AWS Key Management Service. ACID Transactions. It provides native server-side support for transactions, simplifying the developer experience of making coordinated, all-or-nothing changes to multiple items both within and across tables. Point-in-time recovery, or PITR, helps protect your DynamoDB tables from accidental write or delete operations. PITR provides continuous backups of your DynamoDB table data. You can recover to any point in time up to the second, during the preceding 35 days with no downtime. On-demand backup and restore. You can create full backups of hundreds of terabytes of data instantly with no performance impact to your tables. The archived data can help you meet your corporate and governmental regulatory requirements. DynamoDB is also backed by a service-level agreement for guaranteed availability.
Okay.
NoSQL Database Overview. What is NoSQL?
Oof.
NoSQL databases are non-relational
All the
databases.
videos.
They do not require a fixed predefined schema and do not have structured tables with rows and columns. NoSQL databases are purpose-built and optimized for many modern applications. They are a great fit for mobile, web, and gaming applications that require large data volume, low latency, high performance, and flexible data models to provide great user experiences. Here is an example of modeling the schema for a simple book database and a relational database. A book record is stored in separate tables and relationships are defined by primary and foreign key constraints. The books table has columns for ISBN book title and edition number. The authors table has columns for author ID and author name, and the author ISBN table has columns for author ID and ISBN. The relational model is designed to enable the database to enforce data integrity normalized to reduce the redundancy and generally optimized for storage in a NoSQL database. A book record can be stored as JSON document for each book. The item ISBN book title edition number, author name and author ID are stored as attributes in a single document. In this model, data is optimized for intuitive development and horizontal scalability. Why should you use a NoSQL database? Flexibility. Flexible schemas enable faster and more iterative development. Scalability. NoSQL databases are generally designed to scale out by using distributed clusters of hardware instead of scaling up by adding expensive and robust servers. High performance. NoSQL databases are distributed and designed for massive parallel high-performance data processing across multiple processing nodes and servers. This enables higher performance than trying to accomplish similar functionality with relational databases. Highly functional. NoSQL databases provide highly functional APIs and data types that are purpose-built for each of their respective data models. NoSQL databases use a variety of data models. Key value. A key value database uses a simple key value method to store data. The key serves as a unique identifier that is highly partitionable and allows horizontal scaling at scale. Use cases include gaming, advertising, technology, and IoT.
Are you serious?
Amazon DynamoDB is a key value database. Document. A document database is designed to store and query data as JSON-like document. This makes it easier for developers as they are using the same document model format as their application code. Typical use cases include catalogs, user profiles, and content management systems where each document is unique and evolves over time. Amazon DocumentDB with MongoDB compatibility and MongoDB are popular document databases. Graph. Graph databases are purpose-built to store and navigate relationships. Nodes store data entities. Edges store relationships between entities. An edge always has a start node and node type and direction. An edge can describe parent-child relationships, actions, ownership, and the like.
So
Typical
again,
use
what are
cases
y'all
include social
plans for
networking recommendation engines, fraud detection, and knowledge graphs. Amazon Neptune is a fully managed graph database service. Popular graph databases include Neo4j and Giraffe.
What are y'all plans for the
In
weekend?
memory. An in-memory database relies primarily on memory for data storage, in contrast to databases that store data on disk or SSDs. They are designed to attain minimal response time by eliminating the need to access disks. In-memory databases are ideal for applications such as gaming leaderboards, session stores, and real-time analytics. These applications require microsecond response times and can have large spikes in traffic coming at any time. Amazon Elasticache offers Memcached and Redis. Amazon DynamoDB Accelerator, DAX, makes DynamoDB reads an order of magnitude faster. Search. A search engine database is dedicated to the search of content data. Search engine databases use indexes to categorize the similar characteristics among data and facilitate search capability. Typical use cases are text search, logging, and analysis. Amazon Elasticsearch Service is a powerful high-performance search engine for full-text search use cases.
All right.
NoSQL Database Overview. Difference between SQL and NoSQL databases. There are a few key differences between SQL and NoSQL databases. Optimal workloads. Relational databases are designed for transactional and strongly consistent online transaction processing, OLTP, applications. They are also good for online analytical processing, OLAP. On the other hand, NoSQL, key value, document, graph, and in-memory databases are designed for OLTP for a number of data access patterns that include low-latency applications. NoSQL search databases are designed for analytics over semi-structured data. Data model. The relational model normalizes data into tables that are composed of rows and columns. A schema strictly defines the tables, rows, columns, indexes, relationships between tables and other database elements. The database enforces the referential integrity and relationships between tables. NoSQL databases provide a variety of data models that includes key value, document, graph, in-memory, and search.
Show you in a second.
Or you can design custom data models based on your specific query patterns.
Entertainment conference
ACID properties.
convention.
Relational
Comic
databases
books,
provide
anime,
atomicity, consistency,
movies,
isolation,
gaming,
and durability. Atomicity requires a transaction to execute completely or not at all. Consistency requires that when a transaction has been committed, the data must conform to the database schema.
It's a big nerd
Isolation
gather.
requires that concurrent transactions execute separately from each other. Durability requires the ability to recover from an unexpected system failure or power outage to the last known state. DynamoDB transactions provide developers ACID across one or more tables within a single AWS account and region. NoSQL databases are an excellent choice for high-throughput, low-latency use cases that need to scale horizontally beyond the limitations of a single instance. Performance. Performance is generally dependent on the disk subsystem, and optimization of queries, indexes, and table structure is often required to achieve peak performance. However, performance is also a function of the underlying hardware cluster size, network latency, and the calling application. Scale. Relational databases typically scale up by increasing the compute capabilities of the hardware or scale out by adding replicas for read-only workloads. NoSQL databases typically are partitioned because key-value access patterns are able to scale out by using distributed architecture to increase throughput. APIs. Requests to store and retrieve data are communicated using queries that conform to a structured query language. SQL object-based APIs allow app developers to easily store and retrieve in-memory data structures. Partition keys let apps look up key-value pairs, column sets, or semi-structured documents that contain serialized application objects and attributes.
And I'll get to your question in a second.
Create and query a NoSQL table with Amazon DynamoDB. Before we talk about creating tables, let's go through a few basic terms about DynamoDB tables. A table is a collection of data which we call items. Each item has some characteristics, which we call attributes. Each item in the table has a unique identifier, or primary key. DynamoDB supports two different kinds of primary keys, partition key and sort key. The partition key is mandatory. DynamoDB uses the partition key's value as input to an internal hash function. The output from the hash function determines the partition, which is physical storage internal to DynamoDB in which the item will be stored. The partition key enables partitions for scalability purposes. The sort key is optional and provides additional flexibility for querying data. Now let's look at how you can create a simple table with Amazon DynamoDB service. We will use a music library in this example. To create a DynamoDB table, first enter the table name. In this case, music. Next, enter a partition key. In this example, artist. Since each artist may write many songs, you can enable easy sorting with a sort key. In this example, use song title as the sort key. Next, enable auto-scaling. Finally, create the table. The music table is created and ready to use. You can add data to the table by creating a data record called item. In this example, enter the artist name and song title for each item. There are two ways of searching data, query or scan. In a query operation, you must specify a partition key value. Sort key is optional. For example, you can search by artist and also narrow down the search results by song title. On the other hand, a scan operation always scans the entire table. By default, it returns all of the data attributes for every item in the table. If an optional filter expression is provided, it then filters out values to provide the results you want. To delete an existing item from a table, you must specify the primary key value to delete one item at a time. For applications that need to read or write multiple items, DynamoDB provides batch operations. In addition, DynamoDB performs the individual read or write operations in parallel. Your applications benefit from this parallelism.
All right. We'll just
Amazon DynamoDB scans.
Right. So before we
Overview.
start, this is going to be a good pause. So for one, MomoCon, I'm going to share this screen over here. So MomoCon is just, like I said, it says bring together fans, Japanese anime, American animation, comics, video games, tabletop games, and celebrate costume cosplay. So like I said, there's all type of stuff. There's anime, there's gaming, there's they do voiceover stuff. There's some martial arts things in here. So there's a whole bunch. And then you have guests from different things. So like you have, I think the cast from the original Little Mermaid is going to be there. You have a bunch of streamers, actors from different movies, voiceover actors. As you can see, we have, I think was a Kung Fu champion. So he'll be here. You have, like I said, musicians. So like I said, it's just a big convention. And then they have parties at night. Now, I'm not going to be at the parties. I'm there. I'm there strictly for the networking and things like that. But it's going to be held at the Georgia World Congress Center. So here, like, you got the gaming events. Hold on, gaming events. So they got an arcade over here, old school arcade. There's a couple of esports tournaments going on. They have tournaments where you can bring your own PCs. I won't be participating. I don't think any of my gamers will be participating in any of the tournaments. If they are, I'll keep you posted. But then they also have panelist speakers. So I'm actually speaking on 2 different panels this weekend. So I'll be speaking on one panel about just what's going on in the state of Georgia around gaming and tech and esports. And then I'll also be speaking on a panel for parents on how they can help keep their kids safe when they're on the internet or when they're gaming. So I'm speaking on at least 2 panels. I don't know. I don't know how things have been going. I may wind up on another one. And that is not MomoCon. That is actually X Defiant. So we need to get back over to here. So now to the second part. Yes, like I said, so it actually started today. It started about an hour and a half ago. I'm not going down there today. My goal, I honestly only wanted to go one day. I wanted to go tomorrow, which was probably going to be like the big networking day. So I was going to do my esports practice, drive down, be there for, maybe 5-6 hours, and then head back home. And then literally within, I think when I started saying that publicly, I think I said it to y'all on Monday when we were streaming, and I was like, yeah, I'm just gonna go for one day. I'm not really hanging out doing too much. I'll be there for the day. And I think I got a text message like that night that was like, hey, could you speak on this panel? And I'm like, all right, cool, sure. And then I got a call yesterday, I think it was yesterday, about speaking on another panel, and then someone else just asked me about another one. So now I went from being there for one day for a few hours to being there 3 days on 3 different days. So yeah. Now the second question about have I ever had a time where I doubted myself with learning hacking? Yeah, I've doubted. I've had doubts in the past. I've questioned it. I mean, it's natural, especially even as I get older now in my career. There are certain things that I'm like, man, I'm not catching it like I used to, or I'm not as on point as I used to. So I mean, things do come a little bit differently. As far so yeah, I can see where I can say I've had doubts. Like I didn't talk about it all the time. Like when I was trying to figure out SSRF vulnerabilities and exploits, for some reason I just couldn't get it, and that was probably a good one. Active Directory, that was probably another one where I'm just like, it's just a lot going on. But then again, you kind of just recalibrate and sit back and see where you're struggling and figure out what you're doing wrong and how to alleviate that. So again, in the case of Active Directory stuff, I created a methodology, right? And then I went and checked out Mayfly's mind map, and that worked. So I mean, like I said, it's natural to have some type of doubts. It's natural to have, certain apprehensions or, whatever. But I guess yeah, that would probably be the only time I said I doubted myself, or I doubted, my ability. I mean, there'll be times where you'll be on pen tests and you'll come across something and it's there and you can't get it, and then sometimes that irritates me. It doesn't make me doubt my ability, but it pisses me off. Like it angers me because I just look at it as a challenge and something that I have to figure out. as far as like doubting myself compared to maybe other people, and I don't. I stay in my lane. I know where I'm good. I know where I'm not. Um, Most of the people who are um, beyond, most of the people who are above me or more talented, they have. I can, they have something that I'm lacking. They may have stronger programming skills. They may have done it. They may have done, different types of testing for a lot longer than I have. They may have done it. They may have served in the military where they're, they have access to a whole bunch of different things that makes it better for them when they come out as far as the skill sets that they have. So like I said, I don't ever really doubt myself in the sense of like I don't belong. But like I said, I mean, there's times where I've been challenged. There's times where things aren't, concepts or certain things aren't coming to me as easy as they used to, or as easy as I think they should. But again, it's just kind of looking at it from the objective of, okay, well, where am I struggling? That's it. All right, so back to it because we got 4 more videos to go. We still got more challenges.
A scan operation in Amazon DynamoDB reads every item in a table or a secondary index.
Going back to your point, Rick,
by default, a scan operation returns all of the data attributes for
it's
every
going to be
item
fun.
in a table or index.
I just didn't want to.
Therefore, the best practice is to avoid using a scan operation on a large table or index with a filter that removes many results.
And then we got
a single scan operation can retrieve a maximum of 1 megabyte of data.
I'm gonna be,
for example, here is a DynamoDB scan
for me
using the AWS command line interface,
in a good way,
AWS CLI. The DynamoDB scan CLI command is used to scan the music table. You can use the projection expression parameter so that scan only returns some attributes rather than all of them. In this case, only the album attribute values are returned. If you need to further refine the scan results, you can optionally provide a filter expression. A filter expression determines which items within the scan results should be returned to you. A filter expression is applied only after the entire table is scanned or a scan finishes. The expression does not consume any additional read capacity units. With scan, you can specify any attributes in a filter expression, including partition key and sort key attributes. The syntax for a filter expression is identical to that of a condition expression. Filter expressions can use the same comparators, functions, and logical operators as a condition expression. In this example, it filters the scanned results by artist 2. Therefore, only the list of albums by artist 2 are returned. Now, let's look at some of the key features. Limiting the number of items in the result set. You can limit the number of items in the result set by setting the limit parameter to the maximum number of items that you want prior to filter expression evaluation. For example, suppose that you scan a table with a limit value of 4, and without a filter expression, the scan result contains the first 4 items from the table that match the key condition expression from the request. Now suppose that you add a filter expression to the scan. In this case, DynamoDB applies the filter expression to the 4 items that were returned, discarding those that do not match. The final scan result contains 4 items or fewer, depending on the number of items that were filtered. Counting the items in the results. The scan response contains the following elements: scan count and count. Scan count is the number of items evaluated or scanned before any scan filter is applied. Count is the number of items that remain after a filter expression was applied. If the size of the scan result set is larger than 1 megabyte, scan count and count represent only a partial count of the total items. You need to perform multiple scan operations to retrieve all the results. Read consistency for scan. A scan operation performs eventually consistent reads by default. This means that the scan results might not reflect the latest changes due to a recently completed put item or an update item operation. If you require strongly consistent reads, set the consistent read parameter to true in the scan request. Note that a scan operation which performs strongly consistent reads consumes twice as many read capacity units as compared to the default eventually consistent reads.
All right.
Amazon DynamoDB scans features. Here are the key features. Capacity units consumed by scan. If you scan a table, DynamoDB consumes read capacity units from the table's provisioned read capacity. If you scan a global secondary index GSI, DynamoDB consumes read capacity units from the index's provisioned read capacity. In the case of a local secondary index LSI, DynamoDB consumes read capacity units from the base table's provisioned read capacity. DynamoDB calculates the number of read capacity units consumed based on item size, not on the amount of data that is returned to an application. Paginating the results. With pagination, the scan results are divided into pages of data that are 1 megabyte in size or less. An application can process the first page of results, then the second page, and so on. To determine whether there are more results, you need to scan with the debug mode in order to examine the low-level scan result and check if the result contains a last evaluated key element. In this example, the page size parameter limits the number of items per page. The scan result contains information in the last evaluated key. This indicates that there are more results data available for the operation. To retrieve the next page of information, you will need to set the exclusive start key value to the last evaluated key value and scan again until the absence of the last evaluated key in the query result. When there is no last evaluated key, you have retrieved the final page of results. Parallel scan. First, let's understand why parallel scan. By default, the scan operation is sequential. However, the larger the table or index being scanned, the more time the scan takes to complete. In addition, a sequential scan might not always be able to fully use the provisioned read throughput capacity, since a scan operation can only read one partition at a time. The throughput of a scan is constrained by the maximum throughput of a single partition. To address these issues, the scan operation can logically divide a table or secondary index into multiple segments, with multiple application workers scanning the segments in parallel. Each worker can be a thread in programming languages that support multi-threading or an operating system process. To perform a parallel scan, each worker issues its own scan request with the segment and total segments parameters. The segment parameter is the segment to be scanned by a particular worker. The first segment number is always 0. Each worker should use a different value for segment. The total segments parameter is the total number of segments for the parallel scan. This value must be the same as the number of workers that your application will use. After each scan, if there is more data, the worker will set the last evaluated key value to the exclusive start key value and scan again until the last evaluated key value is null. This indicates that there is no more data.
Man.
Amazon DynamoDB. Queries overview.
We got, like I said,
you can query any Amazon DynamoDB table or secondary index and find items based on primary key values. For the query operation, you must provide the name of the partition key attribute and a single value for that attribute. Query returns all items with that partition key value. Optionally, you can provide a sort key attribute and use a comparison operator condition to refine the search results. Let's start by looking at a DynamoDB query example using the AWS command line interface, AWS CLI. The DynamoDB query CLI command is used to query the music table. If you want to specify search criteria, you can use a key condition expression. The expression contains a string that determines the items to be read from the table or index. You must specify the partition key name, the artist. Optionally, you can provide a second condition for the sort key if present, in this case, the song title, and use the following supported comparison operators. A single query operation can retrieve a maximum of 1 megabyte of data. Query results are always sorted by the sort key value. By default, the sort order is ascending. To reverse the order, set the scan index forward parameter to false. If you need to further refine the query results, after applying the key condition expression, you can optionally provide a filter expression. A filter expression cannot contain partition key or sort key attributes. The expression determines which items within the query results should be returned to you. All of the other results are discarded. It does not consume any additional read capacity RCUs. The syntax and comparison operators for a filter expression are identical to that of a condition expression.
I gotta find.
If you need to compare an attribute with a value, define an expression attribute value as a placeholder. They are used as substitutes for the actual values that you want to compare. In this example, we are substituting searched artist with a string value of artist2, search song title with a string value of song B, and the searched year with a number type value of 2018. With these expressions and substituted values, you can find the item with artist2, song title song B that is released after 2018. Amazon DynamoDB. Queries features. Limiting the number of items in the result set. You can limit the number of items in the result set by setting the limit parameter to the maximum number of items that you want. For example, suppose that you query a table with a limit value of 4, and without a filter expression, the query result contains the first 4 items from the table that match the key condition expression from the request. Now suppose that you add a filter expression to the query. In this case, DynamoDB applies the filter expression to the 4 items that were returned, discarding those that do not match. The final query result contains 4 items or fewer, depending on the number of items that were filtered. Counting the items in the results. The query response contains the following elements: scan count and count. Scan count is the number of matching items to the key condition expression before the filter expression, if present, was applied. Count is the number of items in the response result. If you used a filter in the request, then count is the number of items returned after the filter was applied. If the size of the query result set is larger than 1 megabyte, scan count and count represent only a partial count of the total items. You need to perform multiple query operations to retrieve all the results. Capacity units consumed by query. If you query a table, DynamoDB consumes read capacity units from the table's provisioned read capacity. If you query a global secondary index GSI, DynamoDB consumes read capacity units from the index's provisioned read capacity. In the case of a local secondary index LSI, DynamoDB consumes read capacity units from the base table's provisioned read capacity. DynamoDB calculates the number of read capacity units consumed based on item size, not on the amount of
All
data
right,
that
we're
is
about
returned
to
to an
get to the
application.
lab.
Read consistency for query. A query operation performs eventually consistent reads by default. This means that the query results might not reflect latest changes due to recently completed put item or update item operations. If you require strongly consistent reads, set the consistent read parameter to true in the query request. Paginating query results. With pagination, the query results are divided into pages of data that are 1 megabyte in size or less. An application can process the first page of results, then the second page, and so on. To determine whether there are more results, you need to query with the debug mode in order to examine the low-level query result and check if the result contains a last evaluated key element. In this example, the query also limits the number of items per page using the page size parameter. The query result contains information in the last evaluated key. This indicates that there are more results data available for the operation. To retrieve the next page of information, you will need to set the exclusive start key value to the last evaluated key value and query again until the absence of the last evaluated key in the query result. When there is no last evaluated key, you have retrieved the final page of results.
All right, we are good to go. I didn't start comparing. Yeah, man. Like, ain't no point in comparing yourself to everybody else. And even the people that you're comparing yourself to, they're just, they're either trying to figure out what they want to do next and move on, or a lot of them are slowly getting out of the game, man. So just take your time and do what it is that you want to do. All right, so we went through all of that. 1 second, y'all. Oh boy. All right, let's go. DynamoDB's key value document. Okay, so we talked about that. All right, let's go ahead into the plan. So we're going to create a NoSQL database in the table. We're going to add records, and then we're going to query the table. And then we're going to create a new user item with a unique ID, and then add a new attribute named rating with a number data type. All right, so we're going to create, okay, sure. We're going to create a NoSQL database, add records. All right, well, let's get through it. Yeah, okay, so we are going to, again, do the same thing, make sure there's no lab files. We're going to start our lab, open up our console, switch over here, make sure we are in the right place when we log in. So we are our lab user and we are in the right region. So we are good to go. All right, so now we're going to type in DynamoDB, which will bring us to the DynamoDB section. And then when we go to DynamoDB, we are going to go ahead and we're going to click create a table. And then after we create a table, we're going to name it user video history. So we're going to create a table. The table name will be user video history. The partition key we'll go with is going to be a user ID, not user ID. All right. we're going to choose string. So that's set the string already. And we're going to go to the last date watched. So last date watched. So that's what we'll be able to do to track their stuff. And we're going to give it a number, partition key. And this is the part where my brain starts to look and see if I can kill two birds with one stone, because it says we need to create another user item with a unique ID, and it's going to be attribute rating. All right. I'll leave it for now. Okay, string, last date watched, and we are confirming that we are good. String and number. Okay, cool. Now the next thing we need to do is scroll down to create table, right? So we need to keep our default settings, which is good. And then we'll go ahead and create our table. And then we're going to go ahead and make sure that our stuff is user video history. It is creating it. So we will sit until it says it is active. And then once it's active, we're going to go ahead and create an item. I think that's when we'll kill two birds with one stone. All right, cool. So we have here, so we now know it's active. So now, because of that, we can click it, go to actions, and we can create an item. And it says we need to give it the user ID value of that. Nope, that is not what it said. 1, 2, 3, 4, 5 dash ABCD. 1, 2, 3, 4, 5 dash ABCD dash 6789. 6789. And then the date watched is 161915. 161915. 6406. 6406. Right? Now again, we can create a new user ID, user item. All right, so we'll go ahead and we'll hit create item. The attribute name is rating. Create a new user item with a unique ID. Sorry, y'all. I'm just I can't help it. I'm trying to get through this, and then we're gonna add a new attribute. We're gonna with a number type, number, and then it's gonna be called rating. I'm sorry, rating. All right. Now let's see if hold on to that for now. I'm sorry, I'm a hacker. I got to figure out how to just kind of do things differently. All right, so now that we have our unique, we have to go back to here. We're confirming that we're going to add a new attribute, and it's going to be, Remove that one. We're going to add a new attribute, and it's going to be a string attribute. And this one is going to be called video ID. So video ID, and then the value is 9875. 9875-DJC 1859. Okay, and then after we do that, then it says we want to add a new attribute, and we're going to go ahead and add another string attribute. Okay. And then this one is going to be called preferred. Learn how to spell. Learn how to spell. Preferred language. And then for the value type, we're going to call it English. And now it wants us to add another attribute, which will be a list. So we go down here. And then the attribute is supported device types. So we'll name it supported device types. And then we're going to insert a field, and we're going to choose string. So insert field, it's going to be a string value. And then in the string value, we're going to call it Amazon Fire TV. And I'll explain what's happening in a second. Fire TV. We're going to create another one for Amazon Fire Tablet. Or if you think you have an idea of what was going on here, then let me know in the comments. Go ahead, save and close. So basically what we're doing is like I said, we're creating the item, but we're creating the database. So, and we're creating the different identifiers. So basically we're saying this is all the information that is going to collect when a user is watching their streams. So we're going to see what their user ID is. We're going to see the last time they were watching something on this platform, what their preferred language is that they watch in, so English. And then what device types they're using. So you have, they can have their Amazon Fire TV. So there's the Amazon Fire Stick or Fire Box or whatever it is, or you could use the Amazon Fire Tablet. So that's how it's going to determine that. Okay. And then you have the video ID. So this is the ID of the video that they would probably be watching. All right. So we're just creating a database for all of this information to kind of be collected when they're streaming. All right. So in the navigation, we're going to click Explore Items. So we'll save and close. And now we'll go to Explore Items. And then when we explore items, we click User Video History. And now just ignore this because this is for our DIY challenge. But we'll go ahead and we'll click the thing that we created. And now it looks like it wants us to create another attribute. And this one is going to be a number. And we're going to create one for last. The attribute name is going to be called last stop time. And then we're going to give it a thing a 90. And give me 1 second. I have another call coming in. And that was spam. All right, so now we're creating the last stop time. So this will see the last time they stopped, or where they stopped. So we'll do that. We'll click save and close. So now we have that information. And now we are going to query. We're going to go ahead and query some stuff. So we'll do down here, scan, in the scan and query, we'll hit query. Then we'll go to the user ID, which is the partition key value. So that is the 12345 dash ABCCD dash 6789. And then we want it to be, is the last date watch greater than? So we want greater, equal to, we want greater than. And then we want it, the last date watched 16094 77200, right? And now we're going to run. So now it's completed it completed everything. So when we complete it, we'll see it says the items returned are down here. And we can review the last date watched, which is the information here that we put in here. The last stop time was 90, the preferred language. So again, that's all the information when we needed to search for certain things. And now it says if we want to change the query criteria, we can do something else. So we're going to try this one here. If it'll let me use it. Was it ABD5? So the user ID. Okay, now we'll run it. And as you can see, it did not return anything because there's no record that matches that partition query, or it doesn't have that sort key. So we'll click scan. And when we hit run, it'll bring up the information in our database. So as you can see, it has the user string, and it also has the other one that we created, but we're supposed to be ignoring because we're doing that later, right? And we have completed the lab. So now we'll come back over here. So you see it says we completed it. Now we'll hit the DIY section. And now it's asking us to paste or type the validation. So the item user ID is unique ID. And the Dynamo table name. The DynamoDB table name is, what do we name it again? I don't remember what we named our table before. Oh, user video history. So let us put user video history, and then we hit validate. Could not find a record with user ID. Oh, that's because I did unique's ID and not unique ID. There we go. So again, I see what we're seeing what the challenge is, and while we're there, we're just going ahead and doing it rather than having to go back. So it's like, while we're here, we might as well just do the challenge while we're here, right? So all right, so now fantastic. So now we get another reward. And let's switch it up. I'll go with this one. All right, so now we're up to 14. We're getting there. We're getting there. You are close. So it says we have 4 more assignments to do, but I'm confused how we have 4 more assignments to do when there are 2 more assignments here. Not sure how that works, but okay. All right, so let's see. Again, for those who are just tuning in, we are doing the AWS Cloud Practitioner recertification, but we're doing it through this game called AWS Cloud Quest. So we're using this game to learn about the AWS cloud, and we're using the AWS environment to create different solutions for different customers. Okay, so I need to set up my surf shop in the cloud, and I need some help. Cost. Okay, I think I can cut the number of servers I use at night in half from 4 to 2. And then, okay, you don't need to, just shut it down. I won't pay for it. Interesting. Okay, how do I match my current hardware with what is available? You can easily mimic the architecture and the online documentation. Before you start, though, consider most customers overbuild. Okay, so all right, so we're going to go ahead. Looks like we're going to use the AWS pricing calculator for this one. Let's see how it goes. Hopefully the videos aren't too long. Let's see what they got. Oh.
Let's look at AWS
Only one
pricing
video,
and the
y'all.
AWS pricing calculator. AWS offers you a pay-as-you-go approach for pricing for over 160 cloud services. With AWS, you pay only for the individual services you need, for as long as you use them and without requiring long-term contracts or complex licensing. AWS pricing is similar to how you pay for utilities like water and electricity. You only pay for the services you consume, and once you stop using them, there are no additional costs or termination fees.
I'm curious.
The AWS pricing calculator lets you explore AWS services and create an estimate for the cost of your use cases on AWS. This enables you to make informed decisions about using AWS. How do you pay for AWS? Pay-as-you-go allows you to easily adapt to changing business needs without overcommitting budgets and improving your responsiveness to changes. Commit to save. For AWS Compute and AWS Machine Learning, savings plans offer savings over on-demand in exchange for a commitment to use a specific amount of a service. Usage is measured in dollars per hour of an AWS service, or a category of services, for a 1 or 3 year period. Pay less by using more. You can get volume-based discounts and realize important savings as your usage increases. For services such as S3, pricing is tiered, meaning the more you use, the less you pay per gigabyte. Whether you are running a single instance or dozens of individual services, with the AWS pricing calculator, you can model your solutions before building them. Explore the price points and calculations behind your estimate and find the available instance types and contract terms that meet your needs. With transparent pricing, you can see the math behind the price for your service configurations. You can use hierarchical estimates to see and analyze service costs grouped by different parts of your architecture. You can save each estimate's unique link to share or revisit directly through your browser, and you can export your estimate to a CSV file. The calculator is useful both for people who've never used AWS and for users who want to reorganize or expand their AWS usage.
One second, y'all. My fault, y'all. That was the United States government. All right. So anyway, what we need to do here is the solution is using the AWS pricing calculator to create estimates for the AWS use cases. You can model your solutions before building them, explore the AWS price points, and review calculations. Okay, using AWS, you can take control of costs and continuously optimize your spending so that you pay only for the resources you actually need. Using a static number of resources as your demand fluctuates can overburden your servers when demand is high, which can result in underserved customers. Cost inefficiencies occur when demand is low by spending money on unused computer capacity. With AWS, your resources are elastic, meaning you can provision services that you need on demand and you pay for only what you use. This way, your infrastructure matches your demand. Matching infrastructure to demand uses a concept called scaling. As demand increases, your services scale out horizontally, which means that you increase capacity by adding more resources, such as EC2 instances, to the system. As demand decreases, your systems can scale horizontally in the other direction, which means the number of instances and other resources reserved will also decrease. Using the AWS pricing calculator, you can generate an estimate with no commitment to and explore AWS services and pricing for your architecture needs. You can use the services to help plan how you spend, find cost-saving opportunities, and make informed decisions. Cool. So now we're going to create logical pricing groups. We're going to create weekly, monthly, and yearly estimates. And then for the EC2, and then for the do-it-yourself, we're going to change the EC2 instance type to T2 micro, and then generate a new price estimate URL. So we're going to try to knock out two birds with one stone. So let's go ahead and do it. So again, make sure there's no lab files. We're good to go. It says this does not use the console. Really? Okay. Review the practice lab objectives. Does not require access to the console. So it will only use the AWS calculator.aws. All right, so we're going to share here. We're going to do that. Calculator.aws. All right. We're going to create logical pricing groups, and then we're going to create weekly, monthly, and yearly estimates. All right. So we open a new browser. We did that. Okay. We're going to go ahead and create an estimate. And then once we go there, we're going to go to my estimate. Go there. And now we're going to go ahead and create a group. So this group, we will name it web servers. Learn how to spell, damn it. Web servers. Create group. No, I don't create group. Search group. Y'all should already know what I'm doing. Okay, so now we're going to go ahead and we're going to add a service. And when we add the service, we're going to go for EC2, and we're going to configure that. So EC2, and we're going to configure. And then we're going to call this a web server estimate. Make sure the region, make sure it's US East Virginia. Okay. Now we need to go down to the specifications right here. So we're going to make sure that it's a Linux operating system. We're going to do daily spike traffic. And we are going to pick every day of the week. And we're going to scroll down a little bit more. And then our baseline is going to be 2. And our peak is going to be 4. And the hours are going to remain at 8. And we're going to make sure it's just 8 hours, no minutes. Okay. And then we're going to go to our instances. And we need it to be 2 CPUs, 4 gigs of RAM. It can stay at any network performance, and it needs to be a T2 medium. And then we're going to scroll down to our payment options. And then on our payment options, we are going to choose, we're picking Nani. Payment options, on demand. And then we're going to scroll down a little bit more. And then it's going to go to our show calculations. We're going to click that. And we're going to do our estimated workload hours. And then our estimated workload hours, we are going to review that at a baseline on Sunday. Oh, it wants us to do it by month. So everything is 24. And then these are 8. Okay. So we're reviewing that instances 1 and 2 will be charged for 24 hours a day, where instances 3 and 4 will be charged for 8 hours a day. Okay. So now we need to come out of here. We can close that. And then we need to go to Amazon Block Storage, which is right here. And we need to make sure we're using a general purpose SSD, which we are. And then we're using the IOPS. We're going to do 30. It's raining its behind off over here. Okay, and then we're going to scroll down a little bit more. And when we scroll down, we're going to go to our snapshot frequency. Snapshot frequency, we want that to be weekly. And amount change per snapshot, this says switch that to 1. And 1 gig. And we're going to scroll again a little bit more to the data transfer, which is right here. And then in our data transfer, it says transfer from the internet for free. The amount is 1, and that's 1 terabyte per month. And then for our outbound, we're going to pick internet again. But instead of free, it's 5 cents to 9 cents per gig. We're going to enter the amount of 100 gigs, not 100 terabytes, 100 gigs per month. Okay, and now we're going to go ahead and show our calculations. So 1 terabyte per month time, because remember a terabyte is 1020 is basically a gig of gigs. So inbound is free. Intra-region is free. Outbound looks like about $9 a month. Yeah, US dollars a month. Yep, so $9 a month. Okay. And then, okay, so we could review. Our total upfront cost is nothing, but our monthly cost would be about $100, $99.33. And now we'll just go ahead and save. Save and add service. And now we hit view summary. And now when we hit the view summary, it's going to tell us what it's going to cost for the year, which would be $1,191.96. So we can go ahead and click share. It's going to tell us whatever. We can agree and continue. Your estimate has been saved. We're going to copy the public link. Okay, so we copied our link and we can save it for future reference. So we've done that. So now the DIY is we're going to change the EC2 instance type, and then we're going to generate a new price estimate, right? So here we are. We're back in here. So we have our instances. It's a Linux operating system, and we want to change it to a T2 micro. So we're going to go to T2 micro. We're going to update. So we updated that. So everything else is the same. So now you see it drop down from $1,100 to $378. And now that we have that, we can share, get our public link, move over here, paste our public link into here, validate. The calculator does not have an AWS service. Wait, what? Let's go back. What? Okay, let's try this again. EC2, sure. Shared instances, blah, blah, blah. ET2, we said T2 micro. Compute savings, sure. Show calculations, sure. Add service. View summary. All right. All right, let's try this again. We're going to create an estimate. We're in our calculator. Okay, create an estimate. Let's try this one more time. We're going to add a service. All right, find a service is EC2, not ECW, as much as I enjoyed that wrestling back in the day. So EC2. Daily spike traffic. Okay, baseline. Let's just do this again. 2, 4, 8, 0. Okay. Instance type. Instance family. It's a T2 micro. Right? Okay. On demand. Showing our calculations. Okay. Save and add service. Okay. View summary. Share. Copy the public link. Now you want us to do the whole web servers group again. All right. Okay. Okay. All right, funny guy. Seriously? Try this again, y'all. Web servers. Try this again, y'all. Add a service. EC2. Configure. Daily spike traffic. 7 days a week. Baseline was 2. Peak was 4. 8 hours. EC2 instances would be a T2 micro. On demand. Show calculations. We got that. Okay, our block stuff. It was general purpose. DP. What was our IOPS? Let's just go back a little bit. That irritates me now. 30 IOPS. Snapshot weekly. 1 gigabyte. Scroll. Go into data transfer. Data transfer from the internet is free. And that's 1 terabyte a month. And then down here, the outbound was internet, 5 to 9 cents. And that was going to be 100 gigs at 100 terabytes. Now we're going to show the calculations again. That would show about $99. Right. So now we're going to hit save and add service. Then we can hit view summary. Like I said, it'll be different. So now we can go ahead and hit share, agree and continue, create our public link, come back over here with our DIY, hit paste, validate. Why didn't that work before? I get why it didn't work the second time, because I just created a new thing and I didn't name it web server. But when I named it the web server the first time, I'm not sure why it didn't work the first time. Whatever. But hey, we got it done. Yep. Great. Fantastic. Let's go option 2. So now I'm level 15, builders level 7. Three more assignments, even though I only have one more assignment left. But all right, cool. I got my little hover. I got a hoverboard or my flying motorcycle. So we're just gonna head over here. So like I said, we're gonna get this. We may just get through it. We may just get through it. All right. This is an important time for the city's pet modeling agency. Sure. Okay. Establish branches, connects to a local client management. So we're going to be doing Amazon's elastic file storage, elastic file system. So we're going to set up the EFS, the elastic file system, and then we're going to create a mount target for the pet photos. Four videos. It's not bad. Not bad. Not as bad as, like I said, that other one was painful. But let's just see what we're going to be doing. We're going to deploy and maintain a file system infrastructure that's accessible from 3 different servers. Okay, so basically this will be their cloud storage or their elastic file system. Each server will be able to access it through these mount targets. So it's going to use 3 web servers distributed separately, across separate availability zones. They need to be able to share the same unstructured data, and it consists of PHP files, configuration files, plugins, and images. Okay. All right. Let's get to it.
Amazon Elastic File System Overview. Amazon EFS provides a simple, scalable, fully managed Elastic Network File System, or NFS, for use with AWS Cloud Services and on-premises resources. Amazon EFS manages all the file storage infrastructure for you, meaning that you can avoid the complexity of deploying, patching, and maintaining complex file system configurations. Amazon EFS supports the Network File System version 4 protocol, NFS version 4.1 and NFS version 4.0, so the applications and tools that you use today work seamlessly with Amazon EFS. Amazon EFS is highly scalable. It is built to scale on demand to petabytes without disrupting applications growing and shrinking automatically as you add and remove files. Amazon EFS is designed to provide massively parallel shared access to thousands of Amazon EC2 instances, where they can access the data in EFS at the same time. This enables your applications to achieve high levels of aggregate throughput and IOPS with consistent low latencies. Amazon EFS is a regional service that is designed to be highly available and highly durable. It stores data within and across multiple availability zones, or AZs. Amazon EC2 instances can access your file system across AZs, regions, and VPCs, while on-premises servers can access using AWS Direct Connect, or AWS VPN. Amazon EFS is well suited to support a broad spectrum of use cases, from home directories to business-critical applications. Customers can use EFS to lift and shift existing enterprise applications to the AWS cloud. Other use cases include web serving and content management, big data analytics, application development and testing, media and entertainment workflows, database backups, and container storage. Amazon EFS is designed for Linux-based applications. For Windows applications, Amazon FSx for Windows File Server provides fully managed shared storage built on Windows Server and delivers a wide range of data access, data management, and administrative capabilities.
Had a thought about something, but
Amazon Elastic File System, Amazon
leave
EFS
that for
benefits.
another day.
Here are the key benefits. POSIX-compliant shared file storage. Amazon EFS enables you to control access to your file systems through portable operating system interface permissions. Amazon EFS provides secure access for thousands of connections for Amazon EC2 instances and on-premises servers simultaneously using a traditional file permissions model, file locking capabilities, and hierarchical directory structure via the NFS version 4 protocol. Scalable performance. Amazon EFS is designed to provide the throughput, IOPS, and low latency needed for Linux workloads. Throughput and IOPS scale as a file system grows and can burst to higher throughput levels for short periods of time to support the unpredictable performance needs of file workloads. For the most demanding workloads, Amazon EFS can support performance over 10 gigabytes per second and more than 500,000 IOPS. Dynamic elasticity. Since capacity is elastic, there is no advanced storage provisioning required. You simply create your file system and Amazon EFS dynamically provides the storage capacity you need, as you need it. Amazon EFS is a fully managed service. It manages the file storage infrastructure for you and provides a simple interface allowing you to create and configure file systems quickly. In seconds, you can create a fully managed file system by using the AWS Management Console, the AWS CLI, or an AWS SDK. Cost effective. With Amazon EFS storage, you pay only for what you use. There are no minimum commitments or upfront fees. With EFS Lifecycle Management, you can automatically move files accessed less frequently to a cost-optimized storage class, reducing file storage costs by up to 92%. You can also use AWS budgets to monitor your file system costs. Security and compliance. Amazon EFS allows you to securely access your files using your existing security infrastructure. You can control network access to your file systems using Amazon Virtual Private Cloud, Amazon VPC, security group rules. You can control application access to your file systems using AWS Identity and Access Management, IAM, policies and EFS access points. EFS access points allow you to create application-specific directory and permissions. It enforces the use of an operating system user and group, or restricts access to a directory in the file system. In addition, you can use AWS Identity and Access Management, AWS IAM, policies to enforce a rule that specific applications only use a specific access point. You can also secure your data by encrypting your data at rest and in transit. Amazon EFS satisfies many eligibility and compliance requirements to help you meet your regulatory needs.
Amazon Elastic File System. Amazon EFS features. Storage classes and lifecycle management. Amazon EFS offers two storage classes, the standard storage class and the infrequent access storage class, EFS-IA. The standard storage class is used to store frequently accessed files. The infrequent access, IA, is a lower-cost storage class that's designed for storing files not accessed every day. You can start using EFS-IA by simply enabling EFS Lifecycle Management for your file system. When enabled, Lifecycle Management migrates files that have not been accessed for a set period of time to the infrequent access, IA, storage class. You can define the period of time by using a lifecycle policy. Using the industry-accepted estimate that 20% of data is actively used and 80% is infrequently accessed, you can store your files on EFS at an effective price of $0.08 per gigabyte month.
We getting through it, Joe. We're getting through it.
Amazon EFS offers two performance modes, General Purpose and Max I/O. General Purpose provides the lowest latency per file system operation and can achieve this for random or sequential I/O patterns. Max I/O can scale to higher levels of aggregate throughput and operations per second, and is ideal for highly parallelized applications that can scale out to thousands of Amazon EC2 instances. Throughput modes. The throughput mode helps determine the overall throughput a file system can achieve. Amazon EFS offers two throughput modes, bursting and provisioned. With bursting throughput, the throughput scales with the size of the file system, dynamically bursting as needed, to support the spiky nature of many file-based workloads. Provision throughput is designed to support applications that require higher dedicated throughput than the default bursting mode, and can be configured independently of the amount of data stored on the file system. Encryption. Amazon EFS offers encryption of data at rest and in transit, providing a comprehensive encryption solution. Data at rest is transparently encrypted using encryption keys, managed by the AWS Key Management Service, AWS KMS, eliminating the need to build and maintain a key management infrastructure. Encryption of data in transit uses industry-standard transport layer security, TLS, to secure network traffic, without having to modify your applications. Containers and serverless file storage. Amazon EFS is integrated with containers and serverless compute services from AWS that require shared storage for latency-sensitive and IOPS-heavy workloads at any scale. In a single step, Amazon EFS provides applications running on Amazon Elastic Container Service, ECS, Amazon Elastic Kubernetes Service, EKS, AWS Fargate, and AWS Lambda, access to shared file systems for stateful workloads.
Amazon Elastic File System. Data transfer and backup. Moving your Amazon EFS file data can be managed simply with AWS Data Sync. AWS Data Sync is a managed data transfer service that simplifies, automates, and accelerates copying data between NFS file shares, EFS file systems, S3 buckets, and on-premises storage. AWS Data Sync can transfer your file data and also file system metadata, such as ownership, timestamps, and access permissions. AWS Data Sync uses a software agent to connect to your EFS file systems. It automates scaling and validating transfers so you don't have write scripts, modify your applications, or manage infrastructure. You can transfer active data sets over AWS Direct Connect or the internet at speeds up to 10 times faster than open source tools.
We had almost 2.5 hours.
You can use the service for one-time data migrations, ongoing workflows with periodic synchronization, and replication for data protection and recovery. AWS Backup is a fully managed backup service that makes it easy to centrally manage and automate backups of your Amazon EFS file systems, removing the need for costly, custom solutions. AWS Backup goes beyond backing up Amazon EFS and centralizes the backup of data across other AWS services in the cloud, as well as on-premises. You do not need to perform backup tasks service by service, create custom scripts, and manual processes for the backup activities. Using AWS Backup, you can centrally configure and audit AWS resources, automate backup scheduling, set retention policies, and monitor backup activity.
All right. Again, if you're just tuning in, we are doing the AWS Cloud Quest. We are playing the AWS game, which also serves as a training or recertification training for the AWS Cloud Practitioner certification. So we're just going through it. Like I said, I wanted to catch up since I've been sick all week. I said I wanted to knock it out this week. So we're gonna see if we can get it done. We are on our third challenge so far today. Third or fourth challenge today. So all right, so we know what we have to do, what we're going to do. So we're going to go ahead and jump into the plan. So we're going to launch and configure an EFS file system. We're going to mount the file system to an EC2 instance. We're going to connect the second instance to the same file system, and we're going to share files between them. And then we're going to mount an EFS endpoint to a third instance and test that the files are accessible from that one as well. So again, we're just going to create all three. All right, we're going to create all three and do the sharing at the same darn time. Make sure we don't have any lab files. Start up our lab. We'll go ahead, open up our AWS console, share this tab over here. We're going to make sure we are our AWS lab user and we are in the US East 1 North Virginia section. So this is going to be a long one, y'all. And it's going to probably be a little bit longer than that since we're going to try to also do the DIY section at the same time. So all right, so let's go ahead and start. We'll bring up our EC2, and then we'll go to our instances. And now there should be pets model. It says pets model stack web server, right? So we should have three of them. So we have our three pet web servers. Okay. Just want to look, see, want to scroll over here, just check all the information. So you see they are in three different availability zones: US East 1A, 1B, and 1C. They have different IP addresses, IP ranges. So they're in three zones, but they need to access the same file storage. Okay, so we need to make sure that all of that is confirmed. We confirmed all of that. And now we're going to go ahead and create a security group. So we'll do that by going up here, going to security. Oh, wait, do we have to shut it down first? Don't we need to shut them down? Yeah, I think we need to shut them down if we need to create that, right? No, let's see. We should be fine. Security groups, right? So now we have our security groups. And we have our web server SG security group, which is the one that we're going to be using. That's the one that we have, and now we're going to create another security group, and this security group is going to be called Pet Models EFS SG1 or 1SG. So we're going to create a security group. We're going to call it that. Restrict. It says we're going to restrict access to web servers only. Restrict access to web servers only. And the VPC is the one for pet models. And then we need to go ahead and create a rule. So we're going to create a rule, and the inbound rule is going to be for NFS. for their network file storage. And we need to make sure it's talking to the proper place. So we need to do the web server security group, which is this one. And we'll make sure that we're good. So that's good. That's good. We're going to scroll down and we're going to head and create that security group. So now under this security group, make sure it says pet models EFS. Yep, we're good. Now we'll go up here and we will type in EFS to search for our Elastic file system. And what we're going to do here is we're going to create a file system. And our file system is going to be named the same thing, pet models EFS1. So we'll go ahead and create that there. Oops. No. Wait a minute. Think I jumped ahead. Oh, that's hilarious. I'm not authorized to do that. That's funny. Let's back up a second. I moved a little too fast. Let's just make sure that file system. That's hilarious. All right. Yeah, I'm still here. We're going to go ahead and just create another file system. It needed to be, I think I had it in the wrong place, and it needed to be, so hopefully I can name it that again. All right, so now we have the right one. Which is this one, Pet Models BC. So, yep. All right, cool. We're just going to have to pay better attention, right? So, oh, gosh, I did it again. Didn't I? Can I customize from in here? Oh my gosh. Come on, Davin, get it together. All right, so we need to make sure that's clear. Lifecycle management needs to be set to none. Transition needs to be set to none. Performance settings need to be set to bursting. Tags are optional, but then we need to go to I messed up. Man, performance settings. Oh, I messed up. I have to do it again. I'm gonna have to do it again. All right, so we'll go back and go back to sharing our screen. I effed up. I effed up. Oh boy. So again, we need to go to EC2, instances. Okay, we have our pet model stacks. We made sure all of that was good. Now we need to go to our security groups. We need to create a security group. And then we need to name our security group. Pet models, EFG there. And then the description says we're restricting access to web servers only. And then that information is that we're going to the VPC for the pet models. Then we're going to go down here. We're looking at for our inbound rules. We have to add for NFS. And it's the web server security group. So we have all that information so we can create the security group now. The security group already exists, does it now? Where does it already exist, please? Oh, it's right here. Fantastic. So, crap, that means if it already exists, then that means this didn't delete. Oh, man. We're going to create one more. We're going to try to create one more. Create file system. Create file system. EFS, pet models, customize. Don't know why that was so hard the first two times. Turn off enable backups. We're going to set that to none. We're going to set that to none. So that is across the board. We're going to scroll down. We're going to scroll down to bursting. No tags, no additional settings. We'll then click next. Okay, we have our availability zones. Ouch. 1 second. Everything's kind of lagging up for a second. It started loading again. So where's my music? All right, so bursting. So now we need to We have, it wants us to remove, and then click. Remove the subnet under mount targets for 1C. Click remove. For you guys, click remove. Remove the security group for E. Under security groups, click the X. Now you want us to click the X there. All right, sure. All right. So now for the security group and this one, you want us to pick the pet model security group that we created. Okay. And then click next. And then from there, we're going to go under file system policy. We're going to just go ahead and click next again. Okay, we're going to review. We're going to scroll down. And we're going to just go ahead and click create. It's messy. I don't like that I messed up that many times. Okay, review the message under the name. We're going to click the next. Okay. Go there. Now we'll click attach. When we click attach, we are going to copy this command and close out. So we have it copied. Now we're going to go back up here to our EC2 instances. Click back over here. Go back to our instances. Our web server 1, and we're going to click connect. Start our session manager. Okay, so we open up our session manager, and we'll go ahead and hit, before we do that, let's do sudo I, no, not sudo 1, sudo I, and sudo mount. Let's see if it'll let us do both at the same time. Oh, jeez. Sudo -I. You can tell I'm getting a little restless, y'all. All right, so now we're root. And now we'll paste this command. Mount point does not exist. What are we talking about? Oh, jeez, come on, Devin. I have to install that first. Sudo yum install -y. -y. Amazon. -efs-uti-ls. And what's hilarious is that y'all aren't looking at my command. Y'all not looking at the proper yet. I wasn't showing y'all my command prompt. Yeah, I'm getting tired. Y'all. Okay. Go to the next step. Okay, now it wants us to clear. We're going to make a directory called data. And then we are going to just ls and make sure that it's there. So we see it. So now we're going to paste that command from earlier. And we're going to switch it to say from EFS, we're going to switch it to say data. Okay, so that looks like it went through successfully because nothing came back. So now we'll go into CD data. So now we are in the data folder and we are going to run this command here for this setup log. Paste. Oh, come on. Thank you. Okay, so we'll have that in there. Come on, what the hell is the problem? Sudo bash cat. Oh, I didn't close the parentheses. Oof. Yeah, this I know I said I was gonna get it done today, but this is getting to be a bit painful. It's not even mounting. It's not even doing what it's not. I don't know what's going on. EFS mount, it should tell me it's mounted to site A. So why is it not doing that yet? Try this again. Nothing. Back up a little bit. Let's go back to the mount. Okay, so it's already mounted. Okay, so we know you're mounted. We know that it's mounted. right? So now we can see back into data, clear this out, and now you should sudo bash c cat efsl setup log. All right, I guess we'll give it a few minutes. All right, sure. Now let's come back over here. Now we know that it is in the last one we made, so 2103. So file systems, we will click this one. And now it tells us to check the network. And then it wants us to click manage. Right, so now that we click manage, we go down here, it's gonna say add a mount target. And now it says US East B, and then with the subnet for that. And then it wants us to choose the pet model security group. Why is it still telling me that I can't do it? But it's creating. All right, click that. So we have to wait for it to say it's available. Once it's available, we're going to go to EC2 instances, and then we're going to connect session manager. This is the Still not saying available yet. All right, I'm gonna be right back, y'all. All right. Am I going to Black Hat or DEF CON? I doubt it. Money is extremely tight. All right, so we have everything available. Fantastic. So now we'll go back to our EC2. And then we'll click our instances. Yeah, like I said, I doubt it. There was an opportunity where I thought I might have been able to go to DEF CON, but I think I'm sitting this one out. All right, so now we're gonna do server 2, hit connect. Hit connect. And then we're gonna do the same thing we did last time. So we're gonna come over here, sudo -i, which will give us our root connection. And then we're gonna run that, we're gonna install that same utility. And then we're gonna do the same thing. We're gonna make a directory called data. So we're gonna clear this. We're gonna make a directory called data. And then in there, we made our directory. We're going to make sure that that's there. And now we're going to making sure I do this right this time, because it gave me so many problems the last time. So we were going to make our directory data. We confirm that it exists, right? So we see it. Crap. Gotta do that sudo mount command again. Oh, okay. Hold on. All right, now we're back. Okay, thank you. Paste. Not DFS. Call it data. So now we know we're good. So we're gonna try to do this on the third server too. All right. All right, so the CD into data. And then we are going to LS. Okay, so then it should be there, right? Cat EFS log. And that's the same thing from before. Right? Because we did that. Cat, okay, mount A. And now wants us to do the sudo bash. Same thing. So sudo bash -c. Whew. Cat greater than EFS -l. Okay. EFS. And I created the wrong thing. Interesting. Oh, that's why. You're doing it again, Jackson. Come on, get it together. EFS1 mounted in site 8. There we go. All right, so that was rough. Starting to get a little restless, but we got through it. So now we need to go ahead and do the third part, which we already started. So let's terminate this. Come back, close this, go back to our share screen. Share back over here. Now we need to go back to EC2, ECW, EC2, and we're going to repeat the thing again. So we're going to go to instances, we're going to go to our web server 3, we're going to connect to it. We're going to open up our session manager. We're going to bring up our command prompt over here. We're going to hit sudo -i Okay. While we're at it, we're just going to make dir call it data. Okay, fantastic. And now we're going to sudo yum install -y Amazon EFS utils. Amazon EFS utils. Yes, let it run its course. After it runs its course, we already did the make dir data. So now right, so that's done, right? Fantastic. So now we made our directory already. So let's just clear our screen. Let's show that we made our screen so we can cd into data. ls, there's nothing there. Okay. And now we are going to cat EFS-1 dash setup log. Oh, that's not there yet because we didn't run our script. You have to mount. Okay, so now it's mounted. So now if we cd into data and we look and we cat EFS setup log, you see there EFS mounted in site A, site B, and then we're going to do the same thing again. So sudo bash -c cat to EFS-1 dash setup dot log. Yep, not dash dot log. Okay, and now it's going to say EFS mounted in site C. Enter. Boom. Now, if we cat it out again, you'll see there A, B, and C plus our mistake. Screw it. All right, so we have that. So now we can terminate it, terminate our session. Let's go back to here. We're going to share our screen again into our Cloud Quest. So now it says our validation form. We need to put the file system ID. So we do that. We got to go to EFS. So we'll search. We'll go over here. We'll go to EFS. Our ID. We'll just copy, come back over here, paste, validate. And now we have the 3 instances because we did that earlier. All right. Oh man, that was a rough one. That was a rough one. But we did it. All right, level 17. Congratulations. Yep, we did all of that. So now it says 2 more to get to Cloud Quest to claim the badge. I don't know what other 2 I have to do. Auto healing and scaling applications. All right. Well, while we're here, let me see. Can I see the... Gaming. Okay. They want to host their own servers, various games in our cafe, maximum EC2 instances that allow provision each day. We do not have controllers. Okay. If an EC2 instance crashes, we have no automatic way to replace it. We also want users to stay within the server provisioning limit, so we have to create auto scaling groups. You can launch templates for your users' games web servers. In those templates, you can configure the number of EC2 instances to automatically scale up or down based on demand. You can also set hard limits on the number of instances. Okay, we have another issue. A large party is booked from 8 p.m. to 1 a.m. every Tuesday. They want the servers ready. The moment the party ends, we want the server shut down. How can we share auto scaling groups? You can configure schedule. Okay. I think this might be a...
Amazon Elastic Block Store. Amazon EBS benefits.
All right, so let's see. I just want to see what this does. Okay, so auto scaling. Instances load on the application. Okay. We'll watch these 2 videos.
Amazon Elastic Block Store. Amazon EBS benefits. Here are the key benefits. Performance for any workload. EBS volumes are performant for your most demanding workloads, including mission-critical applications, such as SAP, Oracle, and Microsoft products. Relational and non-relational databases, enterprise applications, containerized applications, big data analytics engines, file systems, and media workflows are also widely deployed on Amazon EBS. You can choose from different volume types to balance optimal price and performance. Highly available and durable. Designed for mission-critical systems, EBS volumes are automatically replicated within an availability zone AZ and offer 99.999% availability. EBS offers a high durability volume, IO2, for customers that need 99.999% durability, especially for their business-critical applications. Since EBS volumes are for persistent data, it is important to back up the data. EBS Snapshots with Amazon Lifecycle Manager, DLM, provides simple and robust backup solution to protect your data and can be used to enable disaster recovery. Cost-effective. EBS offers different volumes at various price points and performance benchmarks. Options range from highly cost-effective $ per gigabyte volumes to high-performance volumes with high IOPS and high throughput designed for mission-critical workloads. This enables you to optimize costs and invest in a precise level of storage for your application needs. Additionally, Amazon EBS snapshots are stored incrementally, which means you are billed only for the changed blocks stored, and save storage cost. Easy to use. Amazon EBS volumes are easy to create, use, encrypt, and protect. Elastic Volumes is a feature that allows you to easily adapt your storage volumes as the needs of your applications change. You can also easily create backups of your volume using EBS snapshots, and easily automate snapshot management using Data Lifecycle Manager, DLM, without any additional overhead or cost. Virtually unlimited scale. You can build applications that require as little as a single gigabytes of storage, or scale up to petabytes of data. All in just a few clicks.
Let's
did
review
that
auto-scaling
before.
and auto-healing on AWS. AWS auto-scaling monitors your applications and automatically adjusts capacity to maintain steady and predictable performance at the lowest possible cost. AWS auto-scaling makes it easy to set up application scaling for different types of resources across multiple services. And you can configure this in minutes. You can build scaling plans using a simple interface to manage resources like Amazon EC2 Spot Fleets, Elastic Container Services tasks, and DynamoDB tables and indexes. Scaling is simplified with recommendations that optimize performance and costs, or establishes a balance between them. You can also configure smart scaling policies to calculate the appropriate scaling adjustments that immediately add or remove capacity from your applications based on targeted metrics like CPU utilization. Let's review how AWS auto-scaling can automatically heal applications. In this example, an application is powered by EC2 instances that sit behind an Elastic Load Balancer. The auto-scaling group is configured to have an optimal capacity of 6 instances, spread across 2 availability zones. If an instance in availability zone number 1 is failing, an ELB health check will determine instance health, and that triggers the launching of a new, healthy instance. Now, the application has returned to its optimal state. An auto-scaling group can also rebalance instances when necessary. If availability zone number 1 goes offline, the auto-scaling service will rebalance the instance load by shifting instances to availability zone 2 until availability zone number 1 comes back online, making your applications more available and resilient. Now, let's review how AWS auto-scaling can integrate with AWS services using lifecycle hooks. With lifecycle hooks, you can perform actions on instances in an auto-scaling group based on an event. For example, when an instance is flagged for termination, a CloudWatch event detects the termination call, which will trigger a Lambda function. The Lambda function invokes AWS Systems Manager, and Systems Manager places the instance into a terminating wait state. While the instance is in the wait state, Systems Manager bundles the application logs on the instance into a zip file and stores them in an Amazon S3 bucket before termination is complete. The auto-scaling service verifies with Lambda that the log-saving process is complete before it resumes terminating the instance. With this automation, you can save application logging information before instance termination to aid in diagnosing any application issues.
All right. We'll jump into, you can use dynamic scaling. CloudWatch. All right, what's the plan? The plan is to create an EC2 auto-scaling group, assign EC2 instances to the auto-scaling group, and then we need to configure an auto-scaling policy to scale down 0 resources at 1 a.m. every day. 1 a.m. every day. All right, let's get to it. We're going to start our lab, open up our console, share this screen, and we're going to start with EC2 and go to our instances. So we're going to go to EC2, and then we're going to go to our instances. And then after we go to our instances, we're going to find our game server, get that information. We're going to get the public IP address and copy the public IP address. And then from the public IP address, we're going to browse to it. So do that. Now we'll share that. You see the game is called The Hunt. All right, so now we'll go back to our instances over here. And now we're going to go to Actions and Image and Templates. Actions, Image and Templates, and we're going to create an image. And then from there, we're going to create the image for the game server. And it's a regular customer game server, regular customer game server. Right. From there, we're going to scroll down a little. And we're going to tag image and snapshots together, which is already there. And we'll go ahead and just double check, see if our side mission is there anywhere, which is not. Okay, so now we have our game server. We'll go ahead and check it. Actually, we'll go to our images. So we'll go to AMIs, then click our game server. We're going to refresh. Waiting for it to become available. So when it does, we'll launch the template when it becomes available. Is it still pending? Yes, it is. Still pending, still pending. All right, let's see what's going on with some gameplay while we wait. While we wait.
Show me your stats. I'll show my stats of this game. I have like a 2.7 QD and like a 2,800 skill rating. Do you think you're the highest ranked player on this game? No, but I'm number 1 in A right now, Hobbs. I'm number 1 in A and like top 10 in the world.
So the game just came out, and I guess this person's the number 1 rated player. But I'm still trying to.
If I get in your lobby, I'm definitely backing out. That's funny.
So right now the game is free, but if you want to play as certain people, you have to pay for the bundle.
Worst leaderboards? I don't know if I have a command for it, but it's a tracker.gg website. I have no idea if I have a command for it. I don't remember if I do or not. Maybe do like try to tracker command or XD tracker. Maybe I have a command for it.
All right, break over, y'all, because it is now available. So let's go back over here. Back to the grind. Back to the grind. All right, so we are going to. Once we do that, we're going to hit launch templates. And then when we launch template, we're going to create a template. And it's going to be called the game server template. Game server template. And we're going to say regular game server template. Regular game server template. Provide guidance to help me set up a template that I can use with auto scaling. All right. All right. And then now that we set that up, We'll go ahead and scroll down to the application in OS images, which is right here. We'll click my AMIs. We'll say it's owned by me. We're picking this game server that's already here in the drop down. And then we need to set our storage instance, which is a T2 Nano. And then we need to go down here and create a new key pair. We go to our new key pair. We're going to call this game server key pair. Game server key pair. It's going to be RSA and it's going to be a .pem file. So that will go ahead and create that key pair. Now it downloaded over to my stuff. So basically what I would use that for is if I wanted to SSH into it from another system using something like PuTTY or SSH from Linux, I could use that key pair as well. All right, so now in the network settings, we are going to expand the network settings section right here, advanced network configuration. Okay, so our subnet, we don't need to launch template. We're going to select existing security group. And our existing security group is our web server security group from before. And now we just want to make sure everything is here. We're going to check our EBS, advanced details, scroll down a little bit more. Okay, so now I need to double check our summary. Our summary is a regular game, custom game server, customer game server, T2 Nano, 1 volume, 8 gigs. And yep, we'll get the message about, okay, 750 hours. And so we can create our launch template. So now we do that. We should be able to view our launch templates. Now we're back here. Okay, so now it wants us to go to our auto scaling groups. I'm confused. Create launch template, view launch template. All right, great. So now it says, let me go back to EC2 for a second. Scroll down here, auto scaling groups. There we go. I just want to stay on track with what the instruction says. So we're going to do that, and we'll click in the auto scaling group and choose launch. Auto scaling. We're going to go with regular customer game server. We're using the game server template. Okay, we're just going to check everything here. We have our key pair. We're going to go ahead and click next. And we need to choose our network. We need to choose our VPC, auto healing, auto scaling, and then our availability zones. I don't know. What is choose that one, I guess? Which one is it? Let's say we have to choose both sub. Oh, we have to choose both of them. Okay. So now we'll do that. We'll click next. All right. All right, so now we go next. Whew. It's a grind, no load balancer. We're gonna set the no load balancer. We're gonna scroll down and we're going to do the health grace for every 240 seconds. Right, no load balancer, no lattice. Okay, don't worry about that. 240, hit next. Okay, our desired group size, desired capacity is 2. Our scaling is minimum is 2, maximum is 4. Okay, target tracking scaling policy. Scaling policy name is going to be CPU utilization. Utilization is going to be the average, and then the target value is 70. Then we're going to continue scrolling. Hold on, 70, scroll down, and then, all right, so we're gonna scroll down and we're gonna click next. Add notifications, optional. We're gonna skip to review. And then we're gonna just scroll down. And then we're gonna create our auto scaling group. Yes, years ago, and then I just reviewed after it. All right, so we created our auto scaling group. And now in our auto scaling group, we have our regular customer game server. And now from here, you'll see it'll give us, if we go to our activities, you see we have one that says successful. The other one hasn't started up yet, but you'll be able to see the history. And then if we go to automatic scaling, and we can scroll down, here's where we will do our stuff. Here's where we'll set up our scaling schedule. So we'll go ahead and create a scheduled action. And then for the pop-up box, we're going to call it second wave of regulars. Desired capacity is 3. Minimum is 3. Maximum is set to 4. The occurrence is every week. Time zone is Eastern. And then the specific start time is going to be 2025 0501. And then it is 2000 for the hours. because that's 8 o'clock. And then we also want it. So now that we're here, we can scale down, can't we? Let's see, the do-it-yourself said, create a scaling policy to scale down to 0 resources at 1 a.m. So, all right. So what we'll do is we'll go ahead and do this. We'll click create. So, and then we're not going to leave here. We're going to go ahead and create another scheduled action, and we're going to call it wind down. Desired capacity is 0, minimum 0, maximum 0, occurrence. We're going to keep the same energy every week. Time zone Eastern, specific time 2025 0501, and it's going to be 0100 hours. That should be it. Right, so now we have our different actions. So now to do our validation, our auto scaling group name, was regular customer game server. So let's come back over here, and then the scheduled action name is wind down, and now we'll hit validate. What did I name it? Right here. Like, it's right here. Provide at least one value for desired minimum and maximum. But I don't want any resources running. I mean, what if we just do oh, I don't want to do that, because that's when the whole thing ends. All right, so I mean, I did everything right. Oh, is that what I did wrong? Every week. Right? Because that's what this one is. This one is every week. It was every week, wasn't it? Yeah, the reoccurrence is every week. Every week. Okay, save changes. Edit. Every week. Oh, I see what I did wrong. It's what it's spelled with a capital. Oh, it needs to be every day. All right. So occurrence every day. Save changes. There we go. Yay. All right, last one, y'all. Last one. Highly available web apps. Create auto scaling groups across multiple availability zones. Create a load balancer. Attach auto scaling group to load balancer. Create load balancer health check for EC2 instances. Okay, so the good news is we've watched all these videos already. So we're just going to jump into the lab. Configure an auto scaling group to include a third EC2 instance. All right, so we'll just do it when we're doing the second one. No. Yes. Yes. All right. Let's go. All right, let's start. Let's make sure there's no lab files. Okay, we're going to start our lab.
This is the practice section. Use it to build.
Okay, well, let's see. Let's see what's going on over here while we're waiting for the lab to be provisioned. All right, so all right, I'm gonna just refresh, and while we're doing that, like I said, we'll just keep checking out some gameplay here.
Mentally increased now. Oh, that's a 3-piece. Now the vibes are actually so wide now.
Or hopefully they don't say nothing too crazy
Actually,
while we're streaming, because we don't want to
I need the vibe boost.
have nothing too crazy going on.
That man's on that head glitch.
All right, so I guess it's gonna it's gonna make us stop. I refresh, it's still staying starting, so I don't know.
Yeah, the Pioneer Plus is what I'm like heavily focused
Everything
on.
seems to be getting real
So I'm
funny
gonna be
on
talking
it
about that a lot.
anyway. But
Obviously, we finally have a game we can have a consistent schedule with. We're gonna see how far this goes. So thanks for support, and guys.
yeah,
Also, we got like 100 plus subs.
starting up, y'all.
Insane. Oh, slow mode. What happened? Yeah.
Oh, there it goes.
I
Think.
slow mode.
Are we
It's
are we
for a
in? Are we
while,
in?
But we're good now.
Yay, we're back. All right, y'all. So we're back. Minimize this. Come back over here. All right. Last one. Just y'all been rocking with me now for almost 3.5 hours. Just hold on, y'all. Last one, okay? All right. So we're gonna start off in the EC2. We're gonna go to our auto scaling groups in EC2. So we'll go down here. So we have our travel agency web servers. Looks like it wants us to check and review. So we're just going to review the date that it was created, the name, and the information. Right, so we have that information. Fantastic. All right, now we're going to check the instance management. And we're going to go ahead and review the instance ID, which is right here. Make sure that it's only one instance, which it is. Now we're going to go click our details tab, and we're going to get more information about that. We're going to scroll down a little. And when we get to our network section, scroll, we have our subnet ID. Okay, we'll scroll a little bit more down to load balancing. We don't have any load balancing information. So we're going to go ahead and edit that. And when we do that, we're going to add a new load balancer. We'll click add a new load balancer. Scroll down so we can see what's going on here. And we want it to be an application load balancer, and we want it to be internet facing. So that means we want it to face the outside internet. Okay. Now that we have that, we want to check the subnets. So we want to do B and C, have those both checked. Make sure that they are in the right ones. Make sure they're all public. So public, public, public. And then for default routing, we're going to create a target group. All right. We're going to go ahead and click update. Now we're going to go over here into our security groups, and we're going to create a security group. And now we're going to name this travel agency load balancer. Okay. Description, we're going to say allow access to the travel agency. I hate when it does that. Okay. And then for the VPC, we need to make sure we're picking the travel agency VPC. We did all of that. And now for an inbound rule, we have to click add rule for inbound. We're going to do HTTP because we're allowing the traffic. So HTTP, custom range, CIDR block is all zeros. And again, that's because we're saying we're accepting it from any traffic source. And then our outbound rule is HTTP. And we're going to from the travel agency web server, right? Travel agency web server. All right. So now we're good. We're going to go ahead and create the security group. Now we go here, click our security groups again. And now we want to choose the travel agency web server one. And then we want to edit the inbound rules. Feel like we just created this, but sure. So we do actions. We're going to edit our inbound rules. Now we're going to add another rule. And when we add the rule, we're going to create one for HTTP, go into the load balancer. HTTP load balancer. And now we'll save those rules. All right. And now for our load balancers, we're going to go over back to the left hand and click load balancers. And we're going to click our travel agency load balancer. And we're going to scroll down to the security and hit the security tab. And we're going to edit the security group again. So we'll do that. Okay. We're going to click the X icon to get rid of this security group. And we're going to pick the travel agency load balancer. And we're going to save changes. And now we need to get the DNS name of So go back to our, where is our DNS name? Ouch. Travel agency web servers, fantastic. And then our DNS name is right here. So we're gonna go ahead and copy that. Okay, so now we're gonna open up a browser and paste and go there, wait for it to load up. And when it does, I will switch over to it, which we now have. So we'll do that. And as you can see, like I said, it's only hosted, looks like, with only HTTP. So it's not HTTPS. But we moved it behind our load balancer. Right. So now, if we wanted to check if we want to check the availability or the health status of that site, we can just go slash and then go to health. And you'll see it says the instance is healthy. All right, so now we're going to go back to our target groups. Back in our load balancer side menu over here, hit our target groups. We're going to choose our travel agency web server. Bring this up so I can see it. And then we're going to go to help checks. And then we are in our help checks. We're going to go ahead and hit edit. And we want to do health. We're going to click advanced for the health settings. And then the unhealthy threshold, we want to set to 2. Our timeout, we want to set to 2 seconds. And then the interval, which is the time between the health checks of a target, we want to set that to 5. So it wants it to check the health status every 5 seconds. And we're looking for success codes of 200, which is like the status okay. So we'll go ahead and hit save. And now we'll go back to our auto scaling groups that we were in earlier. We'll check our web servers, travel agency web servers. And now we're going to scroll down to our network information and hit edit. And now here we are going to check the subnets of our private subnets, right? So we're going to come in here and we are going to remove the public subnet. And now we're going to select our US East 1A private subnet. And now we'll hit update. Now we'll go over to our instances. Not gonna lie, this is kind of a lot. We'll check here. We'll go to our networking. So now if you check our networking, we'll just scroll up just so you can see it a little better. We're going to review, you see the subnet now is the subnet for our public sub. Why does it say public subnet? Okay. Review our public subnet. We're going to terminate the instance. Terminate. And then when it's done, we're going to hit refresh. We don't want to see IP addresses or anything like that. Yeah, as a matter of fact, we wanted to switch to private. So we're gonna refresh. We still see IPs. I thought I told it to terminate, but we'll see. Successfully terminated. Okay. Okay, so there we go. Now everything is off. And then if we check the subnet ID, we go to networking. Subnet ID is actually sleep. Networking, subnet ID, there's nothing there. Do we have to turn it on? Hold on. My fault, y'all. Come on. Got to do better. There we go. Private subnet. My fault. So what I did after we checked the health status, we went back to the instances. We changed it from public subnet to private subnet, and now we're just verifying that it is indeed failing over to the private subnet. My fault. Because we terminated the other one, the auto scaling kicked in, which then has it going to the private subnet. All right, so now we need to go back to our auto scaling groups. And we're gonna choose our travel agency and check our activity. And then we're gonna scroll to the activity history. And you should see here that it'll tell you that an instance was terminated or taken out of service, and then another instance was launched and that was successful, right? Last stretch, y'all. And now if we go back again, it won't go back to our health check. Come back over here. We'll just refresh just to show you. It says that we're still healthy. All right, so now we'll come back over here. So we're going to go back to our auto scaling group. And we're going to close this, back to our auto scaling groups. Auto scaling groups, hit the check mark. And then we want to go scroll networking. Where's our bring this up here, scroll to networking. We're going to hit edit. Now it says the concept behind this is to take advantage of the safety and reliability of geographic redundancy, span your auto scaling group across multiple availability zones within a region, attach a load balancer to distribute incoming traffic across the availability zones. I think this is where it says configure an auto scaling group to include a new EC2 instance and a third availability zone. All right, so now for subnets, we're going to pick private subnet 2. You know what? I'm just going to do private subnet 3. And we'll hit update. Back to our auto scaling groups, hit our travel agency servers, and in our group details, we're going to hit edit. And we want to set our desired capacity to 2. And then our minimum is, no, the minimum is going to stay at 1, and then our max is 2. So we're going to say, choose a unit of measurement or desired capacity value. All right, so we'll just do that, 2, and then we'll hit update. And now we're gonna go back to there and we're gonna check our activity logs. And then we're gonna scroll down to the activity history. And then here you'll see it should say we launched a new EC2 instance. Right, and now if we go to our instances, we have another, so we should have another one running, but I don't see it. These are all terminated. Oh, there we go. All right, and now that one should say private subnet, right? There, private subnet. Yep, so that's our private. That's our private subnet 3. Where's our? Just out of curiosity. Yep. Okay. All right. So that's all right. So that's what we had to do. So I kind of again skipped a little bit, but because we're pretty much wrapped up here. Like I said, we see once it loads up, we'll have the stuff running. You'll see that they all say running. When we click them individually, you'll see if we check the subnet information. You see private subnet 1, again, private subnet 2, private subnet 3. So we just created 3 because we did the do-it-yourself for the redundancy. So that's all good. These are initializing. If we want to, we could check the health status of each of them, but it would say healthy. So we'll go to our auto scaling group. We'll just click this real quick just to copy the name of it because we are now done here. So if we go to do it yourself section and we share your application load balancer name, or auto scaling group name is travel agency web servers, but our load balancer name was, I believe, travel agency servers 1. So if we hit validate, hopefully we did it right, and we did. Boom. So we have 3 availability zones that are covered, and we are now let's go over to our customer. Let them know we did it and celebrate. I want another building. Imagine that. Imagine if every time you did something good, or every time you completed something for somebody, you got a building. All right, so we are now level 20. We have finished that. Close out of there. We have completed the cloud practitioner. So, boom. So now we can claim it. Okay, so now this is mine. Here, so you can see now I have my Cloud Quest Cloud Practitioner. So, as a matter of fact, all right, so everything is verified. So as you can see, I still have, I have a couple that are expired, but I have 16 badges here. So we're good. So now I should just check my progress. I've done that. Oh, so wait, why can't I do the so I have to go to the recertify role, activate that role. By taking the cloud, recertify, you certify you've read it and abide, you in person, blah, blah, blah. Okay. You understand. I have read and agreed to terms. And what is my candidate ID? We're gonna stop sharing for that, y'all. Whew. 4 hours. 4 hours, but we did it. We did it, y'all. We did it. We did it. We did it. Yay. So, like I said, so we knocked it out. Like I said, I wanted to get it knocked out. A lot of it I kind of already knew because I've had this certification already. I've done stuff with the cloud, but I wanted to kind of go through the process of just getting the recertification. And also, I wanted to, I don't want another one that's expired. So that's kind of why we went through it. But so I also wanted to kind of just show it off to show folks the gamification and things that go on with it. So hold on. So I hope y'all enjoyed it. I appreciate y'all rocking with me. Like I said, this marathon of a stream to get through it. Like I said, it was a little rough. Started off pretty solid, but got a little rough. But I knew it was going to get there, but I really wanted to get it done. Like I said, with everything happening with MomoCon and everything this weekend, I did not want to have this still in the back, because I didn't think I would have a chance to get it done with the holidays coming up and summer camps here at the center and wrapping up my cybersecurity cohorts and pen test training, and there's a lot of stuff going on here at Alpha Esports and Technology, as well as the sister company Alpha Cybersecurity. So I just wanted to make sure we got it squared away. And honestly, I could have done it privately. I didn't have to, but you know what? So many people were watching. I was getting a lot of feedback from people who were just kind of just going along with it, using it even like a study partner. So I wanted to finish it for them, or finish it for y'all and everybody who's watching. I hope you enjoyed it. I hope it was helpful. Like I said, I know it probably wasn't my best work, especially getting halfway through it. It was definitely a drag, like the tail end of it. But like I said, I'm glad y'all rocked out with me. I'm glad y'all stuck with it. Even the people who left and came back, I'm appreciative of you as well. So yeah, like I said, for those who are watching, thank you. For those who will be watching when when you come back and watch the VOD, thank you. I hope it was helpful. I hope it was, I hope it was something that you could use to help you along the way. And yeah, we're done. So I will probably be on for a little bit tomorrow doing some some gaming. I will probably go live on social media from MomoCon. And yeah, like I said, we'll just, stay tuned. So again, thank y'all. I'm trying to double check I don't know what my candidate ID is, but whatever. So I'm gonna go ahead. I gotta stop by the mall of all places and get some stuff done. So I'm gonna close up shop a little bit early. But again, thank y'all for rocking out, and I will see y'all tomorrow or next week. All right, peace out.